Hey everyone, welcome. We are going to start with our first talk, and we have Jonathan Kuperman. I hope I pronounced it right. Okay. And Jonathan is an engineer at Bloomberg, working on application frameworks. He has worked at Cloudflare, Brave, Twitter, Adobe in past. He is also an TC39 delegate and co-convener of the Source Map Task Group. And today he's going to talk about the future of source map. Welcome, Jonathan.
Thank you. Thanks, everybody. Yeah, really excited to be here talking about source maps, which I feel like are an amazing technology, but has been a bit unloved throughout the years, and I'm very excited about all the attention and effort it's been getting lately. So, the kind of structure for this talk will be a quick history of source maps, sort of explaining the anatomy of a source map, what's currently inside, what they are, and specifically what is and isn't currently encoded, what information we have and what we don't have. Talking a little bit about how they're generated and how they're used, and then with that kind of understanding going into our new proposals that we've been working on. I think one of the goals for the talk is to get like some feedback from you all on the proposals and kind of the stuff that we're thinking about, if it sounds good or if it sounds potentially misdirected. So please come reach out to me afterwards. I'd love to talk. And if you want to get involved, I have slides at the end for how to do that too. Real quick about me. I think you said it all greatly. John Kuperman, work at Bloomberg. I sit now as a member of TC39, and I've been working on the source map task group, which is underneath the TC39 umbrella. So source maps have kind of a cool story. Back in 2009, Google was kind of starting to develop these gigantic JavaScript applications for the first time and came up with the tool, which is still alive and well today, called the closure compiler. And so essentially they started working on tooling that would allow them to like minify or condense or make code bundles smaller and things like that, and immediately were hit with difficulties debugging that code. And so they came up with this source map specification, or a Google Doc with what looked like a specification in it. And so today this remains like more true than ever. Like the kind of core problem that they help with is that with almost all applications, the JavaScript that runs on the server or runs on your client's machines is almost always in some way changed or altered from the source code that you author. And this is like more and more true with expanding beyond JavaScript. And so we've got like CSS, and CSS now being authored from tools that also do some kind of bundling or minification or compilation. And then with the rise of WebAssembly, we have tools, code being authored in other languages like Kotlin and Rust or C++, and then run as WebAssembly. And so we have this very common problem, which is like you're running your stuff in development, but you really need some way of mapping it back to the source code that you authored so you can kind of have a good debug experience. So a little bit about what source maps are. They're JSON objects. Their kind of main goal is to help debuggers, like browsers, link between what we call the generated code, which is what's actually being run in the client, and the source code that you actually authored. So we kind of think about them in these three different categories, names maybe to be decided later, but we think about generators, which are tools that author source maps. And so these would be like ESBuild or Webpack, SWC, some kind of builder or minifier that actually writes the .map file. Then we think about consumers, which are what read those .map files. And so those are most commonly browsers, but we've seen like a lot of cool new tools like Replay.io, for example, using source maps to kind of provide their own out-of-browser debugging experience. And then they're also used by a whole suite of these error monitoring tools. So these are tools that log, your client crashes to their SaaS service or something like that. And then as you kind of look through, you want to be able to see, well, where in my source code did that bug come from? So the anatomy of a source map, they have quite a few optional fields, but I've sort of reduced them down to their main fields for now. They have a version, which is always 3. So that's the easy one. It's just the number 3. And then, so as you can kind of see, they've got like, if we ignore sources content for a second, they have this list of source files, and then they have this array or this list of mappings. And those mappings job, which we'll get into in a minute, is basically to take a token in this generated code where you've like hit a debugger or a breakpoint, and to show you in which source file and where in that source file was that code authored. And the sources content is essentially just the inline code from those sources. So index.js in the sources contains that function Greek code. The mappings are the kind of complicated part, but the rest of it is essentially just a list of source files and their content. So how do generators work? How do they write these source maps? So if we take a really simple example, we have like file 1, and it's got an add function in it. And then we've got an index file, and it imports that add function and calls it, and calls a debugger. So if we go ahead and we run that through a build tool, anyone will do, you'll get this minified code, which is probably what you would expect. You know, you've got your variables and your functions have been reduced to single letter names. We see our debugger still in there. But then at the bottom of it, we've got this little source mapping URL comment. And so this basically says this generated code, when you want to look up what sources it comes from, go and find a file called bundle.js.map. And in bundle.js.map, we see kind of like we saw before, except now there's 2 source files, and they have the content that we would think that they would have. We also have this names array, which I'm going to get into a little bit later. But for now, we've got our sources, the content of each one of those sources, and then a series of mappings. So mappings are like really the only technically complicated thing that we're going to cover here. So they're these like VLQ encoded strings, and without going too much into it, actually Nick here has a great talk of like exactly how the VLQ encoded mappings work, but the information that is mapped inside of them is that for each token in the generated file, we'll make a mapping, and that mapping will contain information about the line and column number in the generated file, so in your minified file, and then the index of which source file created it, so we can go up to that sources array, and then the line and column in the sources array. So it would be like line 1, 1 in the generated file belongs to the 0th source, and if you go in that source file, it corresponds to line 2, 2 in the source file. So we can always have this relationship here. There's a bunch of cool tools to help visualize source maps. So here's one of them, and it's like some React code, and you can hover over anything in the generated, and it'll point an arrow to the source. But you can see if we pick the very first token here, we can see the mapping for it would be AAAA. Those get turned into 0. And so basically it says the 0th column and the 0th line of the generated file, go find the 0th, maybe I should have gone at different numbers. Go find the 0th index of the sources, and then it's 0, 0. So it's basically like a mapping from a point in the generated file to a specific source, and then to a point in the source file. So that's how the generators author these, and they produce these things. So now let's look at how browsers and other debugging tools work utilizing them. So if we have a similar thing, we have like this function, it's got a debug statement in it, add first and second. And then we have another file that does multiply first times second. And we have our index file, like a barrel file that reads these in and calls both of them. So if we go ahead and we just pass this through any build tool, I used ESBuild here as an example, but any would work, they generate this minified thing, just like we would expect to see. Everything's kind of shrunken down into single letter names where it can be. So then if we were to open this code in our browser, the debugger would hit, and we would get this. So we would get a debugging statement that's kind of in this JavaScript IFI with all these single letter names. One thing that's actually really nice about the browsers, they go ahead and they prettify it for you. But the problem here is that it's really hard to trace back where this debugger has landed to the actual source code. So if we go back to our project and we just add source map true, which is the flag for most like TypeScript, ESBuild, things like that, and we run it again, it generates the exact same minified code as we saw before, but now back again we have this source mapping URL comment, and then we go ahead and we refresh the browser. Oh, sorry, I got ahead of myself. So now it generates this one new file, which is the map. You can see our 3 files that we showed earlier, the file 1, file 2, and index. Then you can see this array with the add function, the multiply function, and the barrel file, a bunch of mappings, and a bunch of names. So now when we go ahead and we refresh our file, we get a debugger paused again, and this time it knows we're not actually in bundle.js. Where we really want to be is in file1.js in this add function. And it has renamed the parameters, and everything is kind of as it should be. So this is kind of like the way that they work nowadays. One really interesting thing, if you look at, is this window over here. So we know, like at least hypothetically, how you could do what the browsers do today with like finding the file, using the mapping, getting all of that stuff, and then finding the original name. But how do they get this scope information? And it turns out this is really tricky to get, but is like pretty much demanded by all people using these debug tools. And so the scope information shows that where we're stopped in the debugger has access to 2 bits of local scope. One is first with a value of 2, and one is second with a value of 2. And so all the different tools have different ways of doing this right now, since it's not encoded in the source map itself. So Chrome dev tools use like a series of regular expressions to try to figure out like literally like, are we in a function? Where is that function? Where does it start? Where does it stop? What else is in here? Stuff like that. Firefox goes and actually parses the source files themselves when you're in the debugger. so that they can have a better guess at exactly the scope that you're currently in. So this makes them, they're difficult to implement, they're non-standard, they have bugs because it's just really hard to get actual JavaScript scope without parsing JavaScript. And yeah, they're quite different. So another area that we see some shortcomings is in stack traces. So I assume most people here have had this experience before where you open up your console and you get an error stack trace and everything is just single letter names and it's not all that helpful. Again, this information is really hard to get with what's currently encoded in the source map, especially when it comes to things like this isn't coming from the debug code, this is actually coming from JavaScript, from an error, right? Like there's nothing in that error that helps me point to the source map or the source file. So there's been a few different open source tools. I work at Bloomberg, and we have this open source tool called Pasta Source Maps. Again, its kind of whole point is to get these names back when you get an error. So like ideally, when you're working at Bloomberg, if you get a crash report, it wouldn't give you the single letter RON. It would actually give you the, like you had an error at Penne or Spaghetti or Orzo. And so we do this because we control both sides, the generator and the consumer, and so we add this like XCOM Bloomberg sources functions mapping, right? We add our own new mapping, and that maps the that maps those variable names from where they are in the generated code to what they actually were in the source code. But this isn't a realistic solution because, and I'll go into this in a little bit later, but like nobody owns this full stack, right? Like these generator tools are completely separate from the browsers, and like until recently, there's no like standards body around trying to get these features through. And it's not just as simple as names, like it actually gets a lot more confusing because all of these like minifiers, in an attempt to make your code smaller, they do quite a bit of mangling of your source code. And so in this like very contrived example, like if you have a bunch of functions, but Terser figures out that it actually can reduce them all to no functions, like now we're in a really tough place where like that debugger is located inside of Baz, but we don't even have Baz in the generated file. Like we don't have any functions there. So it gets really difficult to guess at these sources and these scopes where they might have been. And with all features, it's really difficult to move forward because of this kind of fragmentation and like no standards process. So there's like one new feature that's come out over the years, kind of despite all odds, is this Google ignore list. And so they thought it would be really cool. They've added this, I think a lot of browsers have this now, this like ability to black box certain scripts to say, this is like a framework or this is a dependency, like I don't want you stopping in here when I'm step through debugging. And so they thought it'd be cool if you could actually do that kind of programmatically by having an ignore list of files that when you're in the debug step through, just never step here. And so they added this ability where if you add an X Google ignore list flag to the source map, they know what to do with it, but nobody's adding it, so it's not all that useful. So they go to the Angular team and they're like, hey, like, could you start maybe implementing this if you wanted? You could mark all of the Angular core code as this thing. And so that they have in this kind of like, messy way, they start getting support for this, and eventually Firefox sees it and they're like, oh, this is cool, we'll start using it too. So now you have like Firefox checking for the presence of a Google named ignore list flag, and it gets really tricky basically. And so in general, it's been very tough for us to add new features because of this. So kind of what we've been doing over the last year and a half, we formed a task group specifically working on source maps. So this would be a collective of an open invite collective of anybody who's building generators, anybody who's building consumers, anybody who's building these error tools, anybody who's kind of working with source maps, different languages, different like tools that compile between languages, all sorts of folks in this group. And one of the first things that we did is we kind of tackled this current specification. So this is probably a talk for a different time, but finding like dozens upon dozens of like vague areas or inaccuracies or things marked incorrectly in the current spec that everybody sort of has this like secret knowledge, like, oh yeah, we ignore that. Oh yeah, we know that, but nobody's ever written it down before. And so we've been really hard at work trying to flesh that out and make it all written down. And then we've been working on these new features, and so I'll kind of go through those really quick, which is embed the scope information so that all of the consumers can just simply render what function scope or what expression scope you had at that time. Additionally, get the function and variable names, so it's very easy when you have like an error stack to see what function and variable names were. Add debug IDs, which I'll go into as a small topic, and a new proposal called range mappings. And so these are the kind of things that we've been working on over the last year. So the scopes proposal has been our largest effort, and it basically is like this kind of parent category for a lot of the things that I've talked about before, which is like when you have functions that get inlined by compilers, we would really like a way to spread those back out and know where they came from. Variable names, we would like a much easier way to know, like, okay, well, I'm in this scope, I have access to these two variables. What were their original names in the source code? In general, being able to just reconstruct the scope from a debug statement to say, like, what did I have access to globally and what did I have access to locally here? And the way that we are doing this currently with a proposal that's on our GitHub repo is through two new fields added, which would be original scopes and generated scopes. And then we can allow mapping between those so that all of these debug tools, like the browsers and replay, could just, when you're stopped at a debugger, they would do one mapping lookup for the actual source code, and then one mapping lookup for all of the scope and name information that's involved there. The other one that we've been working on, which is going to be a larger effort because it would be outside of just our domain, would be the ability to add debug IDs. And so this helps in a few different places, but one of the main ones that you'd be able to see it would be in the proposal. The idea would be when errors get generated from the browser, you would have a debug ID attached to it, and you could use that debug ID to look up the source map that you would need to find to find all of your source information. But it comes from more than just the stack traces. Like, I think a lot of these tools, especially the error monitoring tools, run into issues when they have constantly being repushed generated in source files, and they're not always sure exactly, like, okay, we saw this error on like January 10th, but we're not exactly sure which source map or what the state of the source code or what the state of the generated code was back then. And so tracing through this kind of information with these long-running processes can be really hard. Similarly, if you just have a project that ends up spitting out multiple source maps, it can be really difficult to figure out how to get back to the source code. And then we have another proposal here for range mappings. This has another couple of uses, but one maybe the easiest to explain is that when you run your code through multiple compilers, like essentially multiple steps, so like an example would be running your code through TypeScript, which would generate a source map, and then running that produce JavaScript through something like Terser to minify it, which would also produce a source map. Combining these mappings can get really difficult and often results in extremely low fidelity. So like you can only map from places in the source that were existent in the original. And so what we end up doing in browsers a lot of the time is we kind of drop down to like, okay, well, we know like what line it was on. Like we know you're stopped on this line. We're not exactly sure where in the line, what column, or like where in the function that you're stopped. And so another example that we're talking about earlier today was that if you have, like, let's say you just have simple code and all it does is just remove comments. So the compile step just removes a bunch of comments. You get in this situation where you're like, okay, do I make individual mappings for every single token in this like giant bit of source code that's unchanged from the generated code that's unchanged from the source code? There's no way currently to be like, oh, and then the rest of this line is like the same as it was in the source code. And so we're working on this range mappings proposal, which would add a new field of mappings, or a new type for mapping, sorry, called range mappings, where you could say like, okay, we removed a comment, but then starting from here, this entire range can map exactly to how it was in the source code. Cool, yeah, so our group basically is open. It's under TC39. Currently, we have members from, this is just alphabetical order, Bloomberg and Google and JetBrains, Meta, Mozilla, Replay, Sentry, a bunch of other cool groups. We're really looking for feedback on this stuff, especially as source map usage is so widespread. If people have like ideas or concerns, or maybe your language, your compiler, something that we need to know, we'd really love to hear from people. Getting involved, if you're already a TC39 member, we have a matrix chat, and then we have all of our events on the TC39 calendar and a contributing guide for getting involved. If you're not a member, you could just join the matrix chat and message me, and I'll do whatever I can to help you get involved. But we meet monthly right now and talk about all of these new features, and then we have another meeting once a month to talk about any issues or vague parts of the spec. Cool, yeah, thank you very much. That's my time.
All right, thank you very much. Do we have questions?
Earlier, you were showing the case where a function was minimized, including the name of its arguments, and how even with hacky solutions, the debuggers were able to show the names of the arguments. So now I'm wondering, what is the current case when you, in the debugger, go to the scope of that function, open the terminal, and do console.log and the name of an argument in the source code? So
you got a debugger statement that you're stopped at, and in the debugger, you do see that the variable names are coming through, right? And then at that point, you open the console and you console log the source variable names. That's a really good question. I'm actually not sure if that would work right now. I doubt that it would. I think that the map is literally only applied to the, to that sources screen, like inside the debugger. I don't think it's applied.
That couldn't be that useful. I mean, it's definitely more useful than not having it, but when debugging, you very often need an immediate console of sorts.
Yeah, no, wait, sorry. I think I'm saying right now that would not work. I think that like with this scopes proposal, I'll let Nick answer, but I'm saying right now I would bet that it would not work.
Okay.
I do think that would be a really good idea.
Because that was the next part of the question.
If
there is any plan to address.
Yeah, like part of the scopes proposal, there would be like, well, it's still like not very stable, that part, but like there would be a list of expressions to evaluate to get values of variables. So like even if the variable doesn't exist anymore, if it's been renamed, there would be a way to get to whatever the variable originally was.
What would happen to the minified names? Would they be shadow, so they would become
so the source map gives all the info necessary to the browser to reconstruct exactly the original scope. But browser DevTools could choose whether they want to also expose like this overlapping minified scope or to completely hide it.
Yeah, I do think those are good questions. The last thing I don't think we've talked about, like if we are trying to enable it, but it would also be a tiny bit out of our direct hands because we're working on the mapping itself and then hoping. But I do think it's a really good, like, what would the console
in the end,
experience?
it's also part of the problem. Because every time you are debugging, well, not every time, but very often you need an immediate console where it's not very ergonomic to know that variable 1 is 10 and variable 2 is 20. Sometimes you want to do variable 1 plus variable 2 or calling some function that...
Yes, so like with this expressions feature of scopes, when like the dev tools would be able to say, okay, this expression written in the console references variable 1. So before evaluating it, we replace the variable 1 piece in this expression with whatever is stored in the source map to evaluate it so it references to the right places.
Yeah.
Glad to hear that. Thanks.
To press, oh no, it's working. All of this stuff with source maps, it seems very similar to what native code compilers do with debug info. And I was wondering if you have done any research around what they do or have been working with any of those people.
Yeah, when a little bit less more recently, but when we first started off, we were working pretty closely with folks that had worked on Dwarf. And I think getting like a lot of like help and feedback from them. I do think there's like some interesting discussions with like, in particularly WebAssembly, like choosing debug formats. But yeah, we have been working pretty closely with them and getting like direction and feedback in these things. I think the original scopes proposal was designed by someone who worked on Dwarf. So.
So just for background, at the beginning of the process, when we talked to people working on Dwarf, there actually was an implementation in Chrome of Dwarf WebAssembly support, but then in the tooling side, also made by Chrome, they decided not to bother supporting it because there was kind of no benefit that they saw over the source map. So in general, when we consulted the different people in the ecosystem, there was a lot more interest in incrementally evolving source maps that seemed a lot more deployable than switching to a new format. But this whole environment scopes thing is sort of filling in the biggest, essential core Dwarf feature that's missing. Not that it's all of Dwarf, but it's...
Yeah, and I think a big focus that we have going forward now is like really working with pretty much everyone integrating with WebAssembly right now to like try to improve the experience there. That's like one of our main targets is like we're working a lot with Artem and Kotlin and trying to make sure that like because there's a lot of challenges there with trying to get source maps to work well for like native generated WebAssembly code.
So I also wanted to ask, why does Bloomberg invest in source maps?
Why does Bloomberg invest in?
Why do you get work time to do this?
Why do I get work time to do this? Yeah, so I think in general, well, first of all, because Bloomberg's amazing and invests in like a ton of great stuff. But I think in general, like this whole like experience of debugging and of like error stacks, all these different things are like vitally important to us. Like like the pasta source maps is like a good example of something that we had already before I joined heavily invested in. So I think that like I'm not sure what you're going for here exactly, Dan, but yeah, I think in general like this experience is great, is really needed. Like it's very, very hard to have large apps and crash reports and debugging and all that stuff. And I do think like our general approach is not to continue down some single repo that we build or whatever, but really try to like take that and extend it out into like some kind of standards or open body. Hello.
So, now I hear about Dwarf, there is another nice feature that Dwarf has and source maps doesn't. You mentioned earlier TypeScript, but there is also the case of binary apps. And something you can do in GDB or any debugger is see the type of a value. Now, this gets complicated in the case of JavaScript. So imagine the native case where you have a pointer. In a debugger, if that pointer is null, you know not only that it's a null pointer, but you can also know the type of what is should be pointed. Because if you have debugging symbols, it will say the type of that piece of the stack or whatever part of the memory where that variable was. Are there any plans to support types in source maps for languages that use them, such as anything compiled with WebAssembly or even TypeScript?
I don't think we have any current plans for that. Yeah, I mean, I think we'd be definitely open to like talking about it, but no, I don't think we've done any work so far into like trying to preserve type information like that. Yeah, I mean, Artem would be great to.
I can like a bit share something. I mean, in source map we don't have anything to encode, but for right now, at least in Chrome, you have information about types. I mean, even for just regular numbers or for types, if we talk about like GC proposal, so you have like structure with type and the value itself. And yeah, with Kotlin we solve it like pretty simple. So we just try to keep the same full qualified name of the type inside the binary as we have like in the source code. So you see, for example, if it's Kotlin string, so you see this Kotlin string, but the type right now is null. But yeah, definitely it's not the perfect solution. So maybe we need to think about it to code something in source
I think
maps.
we could definitely look into doing some stuff in that area.
All right. Any more questions? All right. Thank you, Jonathan.
Yeah, thank you all
very
so much.
much.
Appreciate it.
And yes, it's break time. We will start our next talk at 12. We have to be careful about the time in next talk, so please be here on time. It starts soonish. Few people are still coming, I guess. All right, for next talk we have Martin Stransky. Martin works at Red Hat on Mozilla packages, such as Firefox, SeaMonkey, Thunderbird in Fedora. He is involved in several projects like Firefox Wayland port, Firefox title bar rendering effort, and Firefox nightly distributed as Flatpak. Today he is going to talk about Firefox Wayland postmortem. Welcome, Martin.
Hello. Is it working? Yeah. So, hello guys. Before we start, can you raise your hand who use Wayland on desktop? Wow, wow, pretty much people. Okay, and so please raise your hand who use Wayland with browser, so actually native backend. Whoa, cool. Okay, so pretty much people. Okay, let's start. So, well, actually, why we should use Wayland? Because I think it's more useful for actually for developers, because it's much simpler than X, and actually I think it has the same rendering speed as X. I don't think there's any big difference, and well, it's easy to implement on the compositor side on the server, because it's really small utility which you need to just take the picture on the screen. So this is really, I think, really the benefits is on the server side, and it has some security benefits like window isolation, application isolation, and so on. And actually, it has some issues for users which are not finished yet. And I think the most interesting one is that there is no Wayland implementation. Actually, can you raise your hand who is GNOME and KDE and anything else like Sway? Okay, because there are different bugs on every compositor like Matter, KDE, and if you have any application, you need to just count with it and address that. So it's interesting to fix that, and it has still some missing features than X has, like you cannot place your window on top. It depends on compositor, and it has different pop-up handling, and it's quite difficult to test application on Wayland because you don't have direct access to the screen. So right now you maybe need to use different portal and maybe extend that. Actually, there is no. I don't think there's anything good testing framework or anything testing on Wayland yet. And let's talk about Firefox. Actually, this Firefox port on Wayland is paid by Red Hat. I work on it for almost 10 years, and it was stable and shipped to users in 8 months ago. And 20% of Firefox users on Linux use Wayland. It was X-Wayland before, and I think only Fedora, Edge, and Ubuntu use Wayland with Firefox. And for stable enterprise line and Thunderbird, it will be used in the next iteration, so 28. And in Firefox, we primarily fix Matter bugs and aim to work good in Matter. Then in KDE, and unfortunately, we really don't have time to work on Sway, Western, and any other compositors because they have their own bugs, and we just can't fix that. And well, Firefox Wayland state, I think it's quite stable, and we're just fixing user reports, stability issues, and so. Main issues on the Wayland right now on Firefox side is missing testing. We just don't have automatic testing. We just getting user reports. Fortunately, there are lots of users on nightly, so we have good reports from users. And I think main missing feature is the picture-in-picture. So if you use picture-in-picture on Wayland, you need to put it on top by hand, because it's not on top. So you need to use just the menu, because compositor doesn't allow application to put its window on top, because just for security reasons. There is just proposals how to solve it. GNOME folks wants to use some just like on Android, just some minimal window with controls. Mozilla wants to have full control of the window, so there is just tension about it, and it's not solved yet. And another complication is you cannot place or move top-level window on the screen. So if you do session restore or just want to place pop-up window, you don't know where the top-level window is located on the screen, because if you just read the screen coordinates of the window, you just get anything, just random numbers. So you cannot work with that. You only know the window location if it's maximized. And yes. And Wayland has different focus handling. So application itself cannot take focus. You can only transfer focus. If you have focus, you can transfer it, but you cannot take it just from any different application. It's again from security reasons. And yeah. What we need to solve on the Firefox side is just different clipboard, because Gecko use synchronized clipboard and Wayland async. Different interesting bug is in Matter, they don't implement it subsurfaces for drag and drop. So I will talk about it in next slide. And also there is a complication about Wayland event buffer. If you have some input device which generates lots of events like fast mouse or so, it could overflow the compositor buffer and it will terminate your application. We use Wayland proxy for that, which is some kind of cache of the events. And also, if your application doesn't respond fast to compositor events, it could terminate your application just like frozen or so. It may be issue with GTK3, but yeah. How we paint to GTK? Firefox uses GTK, but we cannot paint directly to GTK widget because GTK doesn't allow it. So we created subsurface and place it over the GTK window, but Matter doesn't paint subsurfaces for drag and drop. So if we do drag and drop like this, so we need to paint directly to the widget, and that's pretty tricky. We need to hack it a bit on the GTK side, stop timers, and it's works, but it's quite tricky. Yeah. Another thing is that Wayland works by differently with window, because Wayland pay the surface, and if Wayland window is hidden, there is no surface. They just delete it. So you cannot bind to the Wayland window before it's shown and after it. And that's complicated for multi-thread rendering. So on the Firefox side, we need to, if there is any painting from different threads, we need to paint to off-screen buffer. And when the surface or window becomes visible, we need to repaint it. Also, it's more complicated if you hide the window, because if you do rendering from different thread, and on the main thread you get event that the window is hidden, you need to stop it right now, because if you paint to just missing surface, you will get protocol error and crash and finish. So this also brings some OpenGL bugs. You can get freeze on GL side from different drivers. They just don't like it. Yeah, and it's less complicated for software rendering. Yeah. Another complication is if you get system events like window resize, scale change, or like that. So you need to really do it fast, because if you paint to the window, to the surface with different scale that is on screen, you also get protocol errors, or application crash. So if you really get scale change from the main thread, you need to use need to synchronize it with rendering thread, EGL, stop the rendering, change size of the window, the surface, and then return back to the main window. And I think the most interesting thing is pop-ups on Wayland. You can have two types of pop-ups. One is based on the subsurfaces. This is just something you place over another surface, and you can place it just anywhere. And but you don't know the screen boundaries. So it could be outside, it could be invisible, and everything. Another kind of pop-up is XDJ pop-ups. They are placed by compositor, and they have really strict pop-up chain. So only one parent, one child. It needs to be adjacent. And I will show you just here. So if you have, for instance, we use subsurfaces for persistent menus like permissions and so. So I will open here the subsurface pop-up, and well, you know, it's outside. And okay. And another thing is this is the pop-up placed by compositor. So if I move it here, it should be placed. Yeah, because the application doesn't know where it's located, so we really need to rely on the compositor. And there is a problem that this pop-up placed by compositor, it could be ignored by Matter. If it's just some wrong configuration, it's hidden and we don't know it. So, for instance, here you see 3 pop-ups: this location pop-up, extension, and tooltip, and they are not adjacent. We cannot use the XDG pop-up, so we just need to connect it somehow and then show it. Well, this is another example. So this is just connected pop-ups, so we can use the chain and use the native pop-ups. But this one is from the is not connected, so we need to use the subsurfaces, and it could be outside of the screen. And another thing is that the XDG pop-ups, they cannot be moved on or resized by GTK3 because it was implemented later. So if you want to just move it or resize it, you need to hide it, do the change, show it again. So like if you have this extension, this is the the XDG pop-up. I will try to show it here. Yeah, so it's placed where is the screen, but if I do, wow. It's even broken, yeah. Interesting. Yeah, so I will place it here, and yeah. Okay, so it's even more broken than I thought. So you see, it's not easy. Good. Okay. Well, the point is, it needs to be just hidden, resized, and shown. Yeah. Well, and what next? We are going to just fix these pop-up issues with remove, resize. I hope so. And we are looking forward to just move Firefox to GTK4 or backport things to GTK3. We really need to look at the testing, and we need to process the freeze or compositor events purposing correctly. Well, yeah, and that's all. So questions?
We have questions. Okay.
Regarding testing, have you looked into libEI maybe for doing some automated testing on GNOME? I think already implements the server side of that.
Well, there is a large test site on Mozilla, but we need to implement. We do have off-screen rendering, and we need to just correctly get the results from the off-screen buffer for Matter and compare it. And we need to implement testing of the pop-ups and different things of Wayland. So there is testing on Mozilla side, but it's on X. We need to move it to Wayland, which is quite difficult because we need to move the test site from Ubuntu, some old Ubuntu, move it to new one and implement it. Yeah.
You mentioned moving to GTK4. So my question is, just out of curiosity, is there any significant difference between 3 and 4 in terms of Wayland support?
I think 4 is completely different API, but almost the same, functionality. So I don't think it's really worth to port whole Firefox to GTK4 because it's lots of work, but really not so many benefits from it.
Yeah, I see.
So feel free to not answer this question if the answer is too long. But I'm curious what the active proposals are for allowing picture-in-picture windows in Wayland without running into the security issues.
Well, I said there are just 2 proposals. Mozilla, they want full control of the window. Just place any control into it, subtitles and so on. And GNOME folks, actually, or Wayland folks, they want just small subset of control, just more security about it. So there are just two proposals, and there are no conclusion right now. Yeah.
Hi. You went in some detail about your struggles with Wayland. I think there's another talk that is going to go into that as well. How do I put it? Like, we had some collective trauma out of what happened with X, and maybe we moved into extreme direction. Do you think there is some scope in creating like a base, a higher level to sort of build on top of Wayland in a cross desktop way?
I do think if we should make some, I don't know, some higher level. I don't think. I think the best solution is just use some toolkit like GTK or Qt or anything like that. Because, well, yes, I think we need to just fix the toolkits.
So, quick question. When I tried Firefox on Wayland some time ago, a couple of months ago, maybe years ago, I remember that there was it was available the Firefox standard one and another icon, Firefox Wayland. So it was basically two applications that I had installed in my system. Is it how it's working today, or you have unified things and dynamically able to change what it runs underneath?
Yeah. Well, just if you start Firefox, there is just switch on GTK side, and you can choose which backend to use. There's just configuration for it. Yeah.
So I don't have a small question. It's probably a larger one, and it's probably going to be a trick one. So while you were describing your struggles with GTK and Wayland, and sometimes the mix of both, and sometimes things that are completely separate from both, I kept thinking to myself, so Firefox is able to render stuff. It is able to render web pages and the frame around the web pages. And Firefox also has its own toolkit. I think it's called XUL, Zool. Zool, is that what it's called?
Yes.
So what is Firefox doing with the GTK in the middle of its own toolkit?
It's not in the middle. It's the final destination of the rendering. So Zool is just the upper level.
Right.
So this is really the low level where you put pixels on the screen, Wayland and GTK. Because there is different end of the rendering. You have different Windows, different macOS, and different Linux. There is toolkit different. So this is really the end state of the rendering.
Have you considered using Wayland directly?
Yes, but we used that before for clipboard, drag and drop, and so. But there are bugs with GTK3 because they don't export everything that we need, and also they are confused if we use more Wayland objects. So it could produce flickering when you change screen and so on. So if you like screen description or data manager objects, so it's possible, but it brings complications. So you just need to choose if you go with the toolkit or with the Wayland, or just make GTK folks to fix it. But it's not.
I mean, like removing GTK entirely, just using Wayland for buffer management.
That's possible, but you need to implement the missing GTK functionality, like input, and so on. So it's another lot of work you need to do. Yeah.
Okay.
Do we have more questions? Okay, thank you. Thank you so much, Martin.
Yeah, thank you.
Martin is saying XUL pops up etc end up being GTK Win32 Mac OS Windows, for example.
Sorry.
It was just
Emilio was clarifying. Yeah, Emilio was clarifying your answer to the Shul question.
Yeah.
That like mentioning what you were saying here, basically.
Yeah. Emilio is
he's all following the
yeah,
the
he works on the Mozilla side on the Wayland and GTK and so yeah.
You all can find this comment on Web Engine Hackfest Matrix channel. Thank you, Martin.
Oh, thank you.
We have Antonio Gomes. Antonio is a browser hacker with past experience in both Firefox and WebKit, focusing on Chromium development for some years now. He works at Igalia. And Max is also a software engineer at Igalia with expertise in various subcomponents of Chromium, including embedding, portability, toolchains, and desktop integration. Today, Max and Antonio are going to talk about the journey towards stabilizing Chromium's Wayland support.
One second. All right, now, yeah. Thank you for the introduction, Rocky. Also, thank you to Martin for the presentation on how Firefox is doing things. And also for, I was hoping that you would talk about Wayland in a bit more general sense, so we can have a bit more time for the very interesting history lesson that Antonio will give. So first of all, the agenda for today. First, I will talk a bit about the relevant architecture parts of Chromium, the different layers, how they work together. And then, yes, as mentioned, Antonio will give a history lesson on how Wayland support evolved in Chromium. It is a very interesting adventure, I think. And then I will talk about what the current status is of Wayland support in Chromium, and finally, what work still needs to be done so we can officially ship Wayland as stable. So let's start with the architecture. I've included the paths if you are interested and want to take a look yourself at the code. Let's go from high level to more low level. Of course, the highest level is Chrome/browser with all the high level browser code, which is using the Views desktop UI toolkit, which does all the rendering and layout and event handling, has most of the UI element definitions that the browser uses. And then on Windows and Linux, Views is using the Aura framework for windowing and event abstraction. If you're familiar with GDI or GTK, it's basically a platform-independent replacement for that. And then finally, on Linux, Aura is using Ozone as one final layer of platform abstraction, and then there's some glue in UI/platform window between Aura and Ozone. So let's take a closer look at Ozone. This is a very simple architecture diagram. We have Aura on the top left calling into Ozone to do all the low-level input and graphics handling. And the nice thing about Ozone is that you can compile in support for different platforms, and then you can select the platform that you want at runtime, for example, via this Ozone platform command line argument. And Ozone is very nice, also for downstream, because in theory, at least, you just need to implement the public interface that Ozone exposes to Aura for your custom platform, and you just brought up a new platform that Chromium can run on, as long as it's Linux-based. I say in theory because in practice, of course, if your platform doesn't meet all the expectations that Ozone currently has, it won't work. Like, as you saw before in the relevant code areas, we had to touch a lot more code than just inside of Ozone, because Wayland violates so many expectations that the browser has. For example, we can completely control the window position and things like that. And yeah, also you can see the 3 most important Ozone platforms that currently live in upstream. We have, of course, Ozone Wayland. X11 also runs via Ozone nowadays. And finally, Ozone DRM is something that is mostly relevant for Chrome OS. And now, Antonio is doing the history lesson.
Yes. So when we talk about this journey that we've been, for some time to get Wayland, to get Chromium running natively on Wayland, I think it makes sense to mention that we're talking about different companies, different years, and even different decades of the development. So we try to do a little bit of storytelling on this, because maybe Firefox, they have also run into something similar, and that spans over various years. So the idea is to go from the very beginning. In 2013, so 11 years ago, some folks at Intel, they've came out with this project called Crosswalk. And Crosswalk was a runtime back then, so it was running web apps. And one of their target systems was Wayland based. So they had the web runtime based on Chromium, and they had a Wayland based target. So they wanted to have Chromium running natively on Wayland. So they started to actually port this stuff on top of the Ozone abstraction layer that Max has just mentioned. So it had a good community adoption, had kind of a hype around it, and people were talking about it. So different projects started to also use it. One of them, for example, is the so-called Tizen operating system. It was primarily developed by Samsung already 2014, 2015. And it was also based on another windowing toolkit, which is the EFL. So Tizen had to run on top of this Wayland ecosystem and a different GUI as well, EFL. So they've took what Intel had originally, they've kind of forked, and they kept developing on their own. So we had already 2 implementations, syncing up, going side by side, one being run by Intel, the other one by the Tizen folks. But eventually, both projects, they've entered kind of maintenance mode or community-driven effort mode circa 2015, 2016. So to give you an idea, this is happened in milestone 49 of Chromium. Today we are on milestone 127. I think that's tip of trunk.
25, I think.
25 is stable,
yeah.
right? Yeah, 26, 27 is beta and bleeding edge. So meanwhile, having Intel, the Tizen folks, we also started to see things happening in tip of trunk Chromium. So we've saw this first commit taking place in Chromium upstream, and we've at Igalia built that because we wanted to see where things were. And basically, we verified that the Chromium Fox, they had a different goal than the one we were originally working at Tizen and Intel and all that. So basically, you can switch. The Chromium Fox, the upstream Google Fox, they wanted to have the Chrome OS development shell that they use daily available on Linux so that they can test things locally using Wayland. That's what they wanted. So if we actually run that back then, 2016, we're not going to see a browser as we just see today and we use today. We were actually going to see a development shell of Chrome OS with various widgets here. We have buttons, we have icons, we have the tray over there. And the browser itself was just another widget running on top of this shell. This is not what we wanted, but that's what we had available upstream. So we started to study a little bit deeper what had underneath things, and we learned about the so-called MUS windowing system that the Chrome OS folks were working on. So basically, they called it MOS plus ash, mustache. And it was a built-in windowing system targeting Chrome OS where they want to have everything related to UI residing on their own servers. So they could isolate everything running, and lower level close to the UI on their own servers. And we wanted to have something for that, for something like that for desktop, but not quite the way they had it. So we've discussed with this person, Robert. He's a previous Google employee, and he said, okay, that's the way we want to go forward. If you want a desktop Linux with Chromium Wayland, you have to adapt and implement things on top of mustache. And that's what we did. We've launched a downstream project. We've put together a prototype. And in 2017, we've came to Fosen, and we've met this guy, this second guy over there, David Riverman. And he was a Google employee working on Chrome OS, particularly on a built-in Wayland compositor for Chrome OS. So basically, in Chrome OS, they run Chrome OS apps, but in the future, they would be able to run Linux apps on Chrome OS on top of this built-in Wayland compositor. So we've met, it was, okay, you have Chromium running on desktop, we have the compositor on Chrome OS, that's good stuff. But we did not connect too much, but that's for the future. We're gonna connect. And after the bring up, the prototyping, we've presented the work in one of the BlinkOn conferences. We've met with the Google folks and stakeholders again, Robert and this other person called Sky, and they said that mustache was being deprecated. You have to work everything out based on a different implementation. So that's what we did. We reworked things on top of Aura views that Max has mentioned. And we ended up with our third design for Chromium on Wayland. The first one from Intel and Tizen, the second one on top of Mustache, and the one that we reworked, which was the final one. And if we look, there is one key difference between the first implementation from Intel and the implementation that is still sitting in upstream today. In Intel's implementation, they used to connect with Wayland from the GPU process. And from that point, Mustache on, for security reasons, we have to rework everything that connects and talks to Wayland to move back to the browser process for security reasons and other concerns. So we are ready in 2019, and Chromium on Wayland was getting again some hype. It was stabilizing things, but we had the Ozone Wayland backend, we had the Ozone X11 backend, and we have the stock Chromium browser that everyone uses. When you install your distro, it comes with a Chromium X11. And we knew that if you want Ozone to actually fly, we would have to get what users use today and put also to work with Ozone X11. So we spent quite some work consolidating the existing Chromium X11 implementation to run on top of the Chromium Ozone abstraction layer implementation. In parallel to this, we've also worked on splitting, and actually properly, it was already split, but we properly split what was running in the browser and what was running in the GPU process. That's for performance, for security, and all that. And remember that I spoke that we met this Riverman guy in Fosden. We've actually started to talk about what became in the future this project called Lacrosse. So during our development on Chrome OS side, you can flip, on Chrome OS side, they were maturing up the built-in compositor. So they've reached a point where we had a desktop Chromium Wayland implementation on top of this abstraction layer, Ozone, and they have a mature built-in Wayland compositor running on top of Chrome OS. And we started to put those two pieces together. So this is more or less what Lacrosse is. So basically, that on Chrome OS, if the user launches the Chrome OS device, in the past, everything was running in one single process, including the browser. So the system, the UIs, the widgets, and the browser itself were one single process. It means that if Chrome crashes on Chrome OS, the whole system would go down, which is totally undesired. So the original goal that they had was taking the implementation that we were working for desktop, put on top of this compositor, and actually isolate the system from the browser. That was the original goal of Lacrosse. Yes, go ahead. That's how it began some years ago. That's how it looks like today. And if someone looking in terms of functionality gains or functionality performance gains, our goal is not to have necessarily a performance or functionality gain, but to make it the flip over so that the users do not notice anything different. They just flip over to the new browser, standalone Lacrosse, and they don't know anything happen underneath things. Today, where we are, we know Google actually is launching what they call Finch trials. So they make available to users a percentage of users to launch Lacrosse by default without the user notice. And if we say tester, you can also get your Chrome OS device and opt in to test stuff yourself, which means test the Chromium Wayland on Chrome OS devices as well. So that's kind of where we are today. Yeah, go ahead, Max.
Right, and taking over like from where we are today with Lacrosse, let's take a look at where we are today with like regular Linux desktop, Ozone Wayland. It is still like officially an experimental feature, and you have to enable it manually. As I mentioned before, you can either pass the Ozone platform command line flag and set it to Wayland, or there's also the Ozone platform hint command line flag, which if you set it to auto, does mostly what you want. I would argue if Wayland is enabled and like if Wayland is available on the compositor side, Chromium uses Wayland, and if it is not, it falls back to using X11. And the Ozone platform hint is also available as like a regular Chromium flag that you can set in like the graphical interface permanently if you don't want to pass it every time on the command line. I was curious by something that Antonio mentioned while we were preparing the presentation, because many distributions use Wayland by default already, but at least I could only find 2 distributions that actually at least give the option to use Chromium with Wayland natively by default. Gentoo has a build time, of course, option to use Wayland by default in Chromium, and also Alpine Linux has a wrapper script for Chromium that automatically passes the Ozone platform hint auto flag. But the rest of the distributions, the user is responsible for manually enabling Wayland support in Chromium. Yeah, a very incomplete list of things that used to be broken, but hopefully should work by now. Screen sharing, which was not so much a Chromium-specific problem, but more like a Wayland problem in general. It works now using Pipewire, but I think we don't have the capability to share local audio. I think it only works for sharing what you are seeing. IME works in a basic form. I will show you in a minute what that explicitly means. Testing also was something that gave me a lot of headaches because Chromium has many test suites, and one of them is interactive UI test, which is like automated end-to-end testing, but no like pixel comparison of the outputs. But still there were some problems because we needed a way to drive the tests, and we had no way to like inject any events of our own. So in the end, what we ended up doing is we use Weston as a compositor for our testing, and we created a new protocol extension that we implemented on the client side in Chromium and also in Weston that allows us to request Weston to like pretend the user has moved the mouse, clicked the mouse, that kind of stuff. Because the previous implementation worked somehow, but especially D&D things, or when you had multiple windows, was practically broken. And also some graphical stuff like window decorations, rounded corners, and things like that. And of course, hardware acceleration should also be working now, I think. Like if you have some not very usual hardware setup, there might be some problems, but it should work. And yeah, don't just take my word for it. I can do a little bit of demos. Let's see. We can maybe first. Yes, I'm aware. Thank you. Because that is full screen. Oh, that is very big. We can first maybe test the screen sharing. Mozilla has a very nice test page for that, where you can do the screen capture, and then maybe I need to turn down the scaling like a little bit. Let's see how well fractional scaling works.
There we go.
Reasonably well, I think.
Yes.
So yeah, the Chromium tab sharing is something Chromium specific. As soon as you want to share the window, like you notice the cursor changed, I can select the window. I think I'm missing the confirm button because of the scaling, but yeah. Now we're seeing like the shared screen. We can do tab dragging is like usually a nice feature in Chromium, but on Wayland, because we can't control the screen like the window position on our own, it is quite broken because we just get a new window and it doesn't move. You can like merge with existing windows, but it's not a nice UX. So I've been working on a fallback for that. Which just uses like the regular drag and drop protocol, where instead of creating a new window, you just doesn't work. I think I still have like I still have a Chromium session somewhere. Now we have like an actual different session. You just get the drag icon, and you only create the browser window when the user actually drops it. And yeah, it opens at a random position, but at least like it doesn't obscure while you're still dragging. And also, I can show you some IME stuff. Like the first basic IME thing is, maybe you're familiar with the compose key, like where you press a key sequence, like a key, and then you can enter key sequences to combine a key, like for German umlauts, for example. Which was incidentally the first thing I ever worked on in Chromium because it was broken back then, and I was very bothered by that. So you can press the compose key and then like combine characters like that. And also, I told you IME is in a basic working state. Let me show you what I mean by that. I've just started Phytex, if that's how you pronounce it, in the background. And a very important distinction, you have to use GTK4 because GTK3 doesn't really work with IME. But like not on Wayland, on Wayland. But I think now, yeah, I can at least type some Japanese, and you can like you now like if you press spacebar, you should get a different like a small pop-up giving you the different options. It is there. It's just on this screen. It's not on that one. But that one's on Chromium. Yeah, like a very small pop-up. It's also not high DPI. It's like blurry. That's what I mean by basic support. So that one's probably not great if you rely on it, but it works to some degree at least. So yeah, now let me get back to the presentation. So yeah, what is missing? There are a few details to work out. Nick and Orko, who isn't here yet, I think, are working on this mostly drag and drop. As Martin already mentioned, like it's difficult to do everything correctly depending on which compositor you're actually running under. So we need to like harden our implementation there. Fallback tab dragging is still also experimental, but it should hopefully ship soon. There are some minor issues with fractional and mixed scaling that still need to be smoothed out, and of course IME. Although that is not just work that we need to do in Chromium, there's also still some discussion going on regarding the IME protocols. Chromium has some specific needs regarding like web standards that they luckily have in mind now with the discussions, so we should hopefully see some progress on that front soon. That's it for now. Thank you for your time.
Thank you.
Yes, questions?
Thank you. That was a really awesome talk. Thanks. So my question was on the screen sharing thing that you showed. That UI flow there seemed kind of confusing, where it like showed you like a gray box and your cursor just changed. Is that something that's going to change?
Oh, that is a compositor-specific thing. That is just like how things work on Sway, or at least how I set it up on Sway. I'm not sure. On GNOME, there's probably a more like user-friendly flow, I assume.
Okay. Like the thing that confused me the most was like this just empty black pop-up that you got there.
Yeah, it is. Yeah, I mean
like
the preview, like you can't, of course, like the thing with the cursor change was like the compositor asking me as the user for permission which window to share, and Chromium, of course, can't show the preview before I've given them permission, so it was just like a black preview. But like as I said, there was some like at the bottom of the pop-up there should have been at least some buttons, so it shouldn't have been like just a black pop-up.
Okay.
There should have been a bit more than that, but that was missing due to like the monitor setup.
Okay, thank you.
Do we have more questions? Okay, sorry.
Yes, hello. It's more like a suggestion. So in the previous two talks, there was a problem to place the window where you wanted with Wayland. So what a workaround I did with XDG shell, as long as you can control the initial position, you can place the window relatively where you want it. So what I used to do is creating like a dummy buffer, like a transparent dummy buffer in maximized size, and then I could resize it and place it exactly where I want. So I'm not sure whether this is a generic solution. So this worked in scenario which was more simple than some of those desktop scenarios, but that's something to consider and keep in mind, even though it wouldn't be like the most beautiful solution that could work, like to actually use a dummy buffer in the beginning, you know it's placed at 0, and then you can resize it and place it, and that would enable you to have features like session restore and stuff like that. Just something to keep in mind. Maybe you already considered it, but I used to do that with Weston on an embedded device. It worked, so yeah.
So it was working across different compositors like desktop and.
So I'm not sure if this is, if that would be a generic solution that actually goes in line with the specification. I think that you can relatively place it according to the current position, which usually the compositor chooses. But as long as you can control the initial position somehow, for example, by this workaround where you know it will, and that's the question, I'm not 100% sure that the compositor is in every case, or every compositor will place it, if you have a maximized buffer and screen size, it will actually place it on the top left always, so I'm not sure. But in the case I tested, it did it reliably, and but it was a simple scenario, so on a desktop might be more complex, there might be more windows, maybe the compositor is not always doing that, but that's something you could look into.
Yes, definitely.
Yeah, it's an interesting suggestion, thanks. But I think, yeah, like the cross-compositor support will probably be difficult. I would also argue it's like not in the Wayland spirit. I think it's better to try and find solutions like upstream on the protocol level. But it's interesting to have in mind, like for if you need like a very specific scenario and need to make it work like more quickly than the upstream discussions usually move.
Yeah, it's not the most beautiful solution. It's just to keep in mind that with some tricks you might be able to do what you want, but it's obviously not in line with the protocol overall.
Do we have more questions?
Please, yeah.
You said that IME was broken in GTK 3?
GTK 3 with Wayland and probably like how Chromium uses GTK for the IME.
Okay, because I was weirded out by that statement and I just ran a small test case, like small app, and it seems to work for me.
Yeah, I mean, it depends on like, first of all, like what you consider IME. But yeah, like I think it's only like it's a special combination of running Chromium on Wayland with GTK3 and trying to use like an external IME program like IBUS or Phytex to do the actual IME stuff. That one does not work on GTK3 right now.
Yeah, basically the way Chromium implements what Max said, the way it implements editing with text compositing, and the way the protocol is designed, they are not very well compatible to each other. So what we hear from the Chromium folks, the Google Chromium folks, is that as long as the protocol isn't fixed, and he points out, the person points out the flaws in the protocols, there's no way that they can work around things on Chromium side. So we've been watching the discussions and somehow participating in the discussions in the protocol level, and then there is the compositor side level implementation of those changes, and then the adoption between the different compositors, and then the client side implementation.
I'm getting a hint of where the problems might be, because I'm
join
running
us to fix it.
I'm running this in NOM. So when I set it to Japanese, for instance, as you did, I actually get the pop-up, but the pop-up is in the very characteristic style of NOM shell, which makes me wonder if it's actually coming from the compositor, just being told by some kind of API, hey, give this list of suggestions. But the input method is actually not allowed to render its own mini window as they used to be, as they used to do.
Yeah, I think the problem is like with we are definitely abusing GTK for IME. We create like a dummy window That's also the reason why the pop-up is in GTK4 on the wrong screen. And we inject custom keyboard events into GTK and then let GTK do the IME handling and grab the output of that. And the problem is GTK3 does not allow us to inject these custom keyboard events. That was only added in GTK4, if I remember correctly.
All right, thank you, Max and Antonio.
Finish?
Yeah, thank
Okay.
you.
Thank you.
We have Aapo Alasuutari. Okay, I hope I did it right. While Aapo is setting up his system there, I can introduce. Aapo works at Walmart Automation as Chief Design Engineer, where he builds, as well as he is also a software architect for a browser-based user interface for Walmart's distributed control systems, more of like industrial automation system. He's also and mostly inactive freelance contractor for Deno land. And today he's going to talk about Nova JavaScript engine, exploring a data-oriented engine design. Welcome, Aapo.
You're hearing me? Good, excellent. Okay. Yeah. All right, let's get going. So, hi everyone, I'm Aapo Alasuutari. Yes, that works. As said, I work at Walmart Automation. So, I have this wonderful title, Chief Design Engineer. Sounds great. We have like 20 of those. I'm working with this user interface. You can see a bit of it up in the top right corner. It's a DCS or automation system, distributed control system user interface, and it's currently running on customer sites all over the world, running Chrome browser, and in the future will support other browsers as well. I also freelance at Deno Land Inc., so Deno where some others here as work as well. A user interface, like it's at least ours, it's not exceedingly performance critical, right? Like it's nice that it's fast, but it's not like it needs to crunch numbers in some nanoseconds. But poor animation performance, for instance, is something that really, really quickly hurts us. And unfortunately, actually, Chrome is, like I'm not throwing rocks here, but Chrome is a bit underwhelming here. See, for instance, the Hummingbird HTML renderer. This is an HTML renderer, kind of like a low-level or small-ish browser by Coherent Labs. They, as far as I can tell, built this whole thing just because Chrome's animation performance was not enough for them in games. So, okay, what is Nova? Nova engine started with Andrew Botella's joke in Deno's Discord. So when are we starting our own JavaScript engine? And we did. Then it laid low for about a year until about a year ago I heard about data-oriented design, which is the thing underlying the Hummingbird HTML renderer as well. So here's the kind of arc where we get from Walmart Automation to Nova engine and then here. And I thought like, wow, like this data-oriented design, entity component systems, that sounds really interesting. How would it work in a JavaScript engine? What would it look like? So, okay, first of all, what the heck is data-oriented design? The ultimate rule is know your data and how it is used. There's nothing more to it. Like this is not some great overarching design principles system where you know this is how you build your systems. You make them out of nice cars and whatnot. No, like this is just you need to know your data. If you don't know your data, you don't know your problem. If you don't know your problem, you can't solve your problem. And once you know your data and how it is used, then you can start designing your solution. You need to design your data structures for the most common use case, not for like the overarching, this is everything that can ever happen. No, that's useless. Design for the common cases. Your program, when it runs, it does not touch one thing once. It does not touch everything once. It touches some things many, many times over in a particular order, in particular ways. Loops, iterations, algorithms, those are the majority of what your program does. So you need to think in these multiples. If you're looking at a single thing, you're wasting your time. In the multiple cases, in the common cases, you need to be optimizing for cache line usage. That's basically where performance of computers or programs, in a way, crashes and burns most of the time. So ignore the singular case. If this is something that happens once, it does not matter. Like, does it take 400 nanoseconds, 2 milliseconds? The user is not going to see or care. It happens once. So, what does this actually mean? Here's what a cache line in node 18 looks like when you have 8 or multiple objects in an array created at the same time, each of them having 2 named properties. First, there's the prototype, or actually the shape pointer. Then there's the elements pointer, properties pointer, the first property inline in the object, then the second property inline in the object, and then the next object starts right after the other. Looks nice, kind of cool. So here we can kind of think, how quick is it to get to the first in-object property out of this? What's the answer? Anyone want to say? Well, that would be one way, yeah. The answer is first, about 200 nanoseconds. The second answer is it doesn't matter. It's a single thing. Don't think about the single thing. Your computer loads data, not byte by byte, but in cache lines. So 64 bytes, that's 64 elements there, or 64 boxes. That's a single cache line. When we want to get the P0, we need to read the prototype, because we need to make sure that this is an object which has the property that we're actually looking for. And we need to get the P0. Everything else here is wasted. We're not taking the elements or using the elements. We're not using the properties. We're not using P1. And we're most especially not using the second property, the second object. But this is a single off. We don't care. This is what we should be thinking about. If we're mapping over an array of these objects and we're taking every P0 out of them, how quick is that? Now we're thinking in multiples. Now this actually matters. And this is how I would do it. Instead of having all of the stuff in a single cache line, kind of right next to each other, have multiple cache lines, have multiple vectors, where one vector contains the prototype pointers of each object, one after the other. Another cache line contains elements pointers, another contains properties pointers, and then there's some place where you store the properties. Now, how quick is it to load or map 8 of these? Well, we still need the prototype pointer, so we take the first cache line. We also need the properties pointer now because there's no in-object memory. So we need load the third cache line, and then once we get that, we can start loading the fourth cache line there. So that's loading 3 cache lines. The first 2 are probably going to be loaded in parallel, so that's 200 nanoseconds. The third one needs to be loaded in sequence, but once we get that, we actually get the whole thing, and we will need to load 1 additional cache line to get the properties of object 5, 6, 7, so on. But now we've loaded 4 cache lines, we got all the data we wanted. That's nice. We can, map all of this stuff kind of very quickly. So, okay, data-oriented design gives us improved cache line usage. But what does it actually cost? Like, of course, there are trade-offs. Well, obviously, an object is no longer just a pointer, right? How on earth would we have a single pointer that points to this cache line and that cache line and that cache line? Like here we saw, like how do you point to the first item there? It's 3 different pointers. Well, it cannot be a pointer, but it can be an index. If we have parallel vectors, one vector of the prototype pointers, one vector of element pointers, so on and so forth, now your object can be an index. The 0th index of all of these vectors contains the data for this object. But if you're using vectors, then it means that your heap data, the data that they contain, it must all be the same size. We're not doing heterogeneous vectors here. That would be horrible. So either each object, its heap data, needs to be as big as the biggest can ever be. And now that's very big. Or you need to have multiple different vectors that you somehow know which one you're going to look into. So this basically means each exotic object in the JavaScript spec gets its own vector. And that gives us some nice benefits in a bit. One thing that this also means, if you're how many of you have done V8 or know V8 somewhat intimately? Like 2 people. V8 has embedder slots. I don't know if SpiderMonkey also has embedder slots. That's not really a thing because like either you would need to have an embedder slot in every object always, or prepare for them, so you're wasting memory most of the time, or you just say like we don't have them, so we don't have them. Now your value then becomes a tagged union. It contains a tag and then the index. That tag tells us which vector are we going to look into, and then the index, of course, tells you the index in the vector. Or, of course, you can also have like a tag that says this is stack data. And in our engine currently, the value is 64 bits in size. We could take it down to 32 bits, but that would mean that we can only have 16.7 million objects, for instance, alive at the same time. Yeah. So, okay. With this, we get better cache line usage. Do we get anything else? Is this it? Well, no. We only kind of so far optimized the cache line usage. We didn't really think about the common cases yet. If you have an array in JavaScript, you are not going to be reassigning its prototype most of the time. You're also not going to be assigning any named properties to it most of the time. All of that is not needed. We can throw it out. Array buffer, data view, things like this, you don't need prototype, you don't need properties, you don't need elements. You need nothing. Like, these should mostly be just marker objects, and that's the main point that they have. Of course, there's the interesting data somewhere back there, but. So, an array, as an example in Nova, looks about like this. We have an object index there, which it's not quite this actually in the engine, but should be. It's either a backing object, so that's an index into the object of vectors, or it's a realm, which is again an index into the vector of realms. And that says, either I already have a backing object and it's there, or I was created in this particular realm, so if you need to create a backing object, then you will use that realm's intrinsic objects. And then there's the element, which is, it's a 12-byte data structure that tells us which element vector to look into and at what index and so on. Now, if we minimize this and split it, we can get it to be 4 bytes for the backing objects in a single vector, and then 8 bytes for the elements in another vector, 2 parallel vectors, and now our array, or maybe our first array would be array 0, so we take the 0th index in both vectors, and there we find the data We have the object index and we have the elements. And now if you're taking like the 0th element of this array, you never need to even load the backing object or the object index. You don't care about the prototype or anything in an array when you're taking the 0th index, unless there is no item there. Then you need to go to the prototype chain, but that rarely happens. So common case is to access the elements or the length. So optimize for that. Pessimize the prototype lookup. Pessimize properties like named properties, because that's not going to happen. And optimize for mapping over multiple of these. So put them on the same cache line in a vector. And yeah, as said, so we can get like 8 element pointers on a single cache line if we really kind of optimize this down. And the elements themselves also live in heap vectors. They look like that. There's a value which is a vector of options of arrays of a given size of options of values. It's a bit of a mouthful. But what is interesting is that the descriptors, so that which says, is this writable, readable, writable, configurable, so on and so forth, that stuff is all in a hash map. So we could call that a sparse vector in a way. Only if you are setting some proper descriptors, like uncommon descriptors on an element, only then will we create this hash map for you. If you're not doing it, we're not going to create it. It's just not useful. I think this is probably what every engine basically does. So like preaching to the choir here, but still. So okay, we get improved cache line usage, but obviously that's not going to help if your items are spread over multiple cache lines. What's the point? Well, GEC systems, the first axiom of why we even do GC is that most objects die young, right? I have a corollary. Most objects live together. If you have a single item, it doesn't matter where it is. If you have 100 items, now that kind of matters. And 100 items, I could kind of see a human being creating a list of 100 items with drag and dropping and so on and so forth. And then you could end up in a situation where the elements in that array are created at different times. But if it's an array of 1,000 items, 1,000,000 items, now you're actually really caring about where those need to be right next to each other. But a human being will never create an array of 1,000,000 items. An array of 1,000,000 items has come from JSON parse. It's going to be created all at the same time, right next to each other. So we just need to make sure that they stay together. So we put our heap data in a vector of items t. And now we just need to make sure that we're not messing about, we're not changing order. So when we do GC, we drain the vector of items that are no longer reachable, and we shift all other items down. That's a hell of a lot of copying of data, so this might be like really slow. We'll see how this works, but as a consequence of this, the vectors are always packed. Any items that were created roughly at the same time, if they're still alive, they will be right next to each other. Mapping through a vector or array of items will usually map through a linear memory. Data that was created together stays together. Of course, this means that all of our references in the heap, all the indexes, need to be realigned on GC. But as a small mercy, this is actually kind of really simple. Like, it's not really that complicated to figure out how many, how much do I need to take out of this number. And it's still like it's a single calculation, more or less. So with this, the heap doesn't really fragment over time. Of course, human interaction can create fragmented things, but it's mostly on a very small scale. And as a nice benefit, actually, from this, we get nursery for free, kind of. If we've GC'd this particular vector down to 100 elements, and then somebody allocates 100 elements more, we know that, or we can kind of decide that, okay, any references, any assignments to items below the 100, those are going into old space. And now we just mark that, okay, this particular element is now reachable from the old space and so on. We don't need to redo the whole GC. So minor GC can be done. Okay, so in conclusion, upsides. We get excellent cache line usage, or at least the potential for it, especially considering that this is a dynamically typed language. The vector-based heap is actually kind of surprisingly simple to reason about, and it really gives us some interesting opportunities. And the tagged union value is really nice because it has no pointer shenanigans whatsoever. I give you a value, and you're a very bad person. You put it somewhere here, and then you're going to like later on follow this pointer to find my heap and do nasty things. Well, you can't. It's not a pointer. It does not point to anything. It's an index. And also, type confusion attacks kind of aren't really a thing here. Like you can take, if you take your value and you change the tag, it does change the type, but it also changes where it points to at the same time. You can't take an array buffer and say this is a shared array buffer and now do nasty things. No, if you say it's a shared array buffer, now it's pointing to data of a shared array buffer. You can still do kind of nasty things for the memory of that, but you can't turn an array buffer into shared. And of course, the 64-bit integer value that we currently have gets us quite a bit of stack data. So we can actually represent all of JavaScript integers on the stack kind of safely, and a bit more. And up to 7 characters of small string optimization, which is kind of nice as well. And properly exotic objects, so functions, data views, array buffers, so on. They have this really nice time of, or really easy time of separating their concerns from the general object concerns, because they just have that backing object pointer or index. They don't need to know anything more than that. But there are downsides. There are downsides. It's all about trade-offs. I've heard that's a thing. So if we pessimize the odd cases, it does pessimize them, of course. Our objects do not have any elements. All properties in an object are just properties. So if you assign 0 to your object, it's not going to this special elements array, it's going to the properties, and it's going to be the last property there, because I can't be asked to reassemble your properties list. So if you do object keys on this, then I will need to check that you don't have any indexed properties there before I give you the object keys list. And of course, if somebody's doing like their own array-like object, it's gonna be slow. Arrays with named properties need that extra indirection. Like if you're putting named properties in an array or array buffer, they're going to the backing object and not to the array itself. Special internal slots, say the promise resolving functions, or anything for that matter, and shared ownership of internal data structures. Those all kind of force us to either pessimize the common case by adding support for this, adding the possibility of having this, or we need to add yet another heap vector. We have a lot of those. So promise resolving functions, rejecting functions. If we want to prepare for these, then all built-in functions would need to kind of prepare for maybe possibly being a promise resolving function, even though there will basically never be. Either that, or we have a special heap vector of promise resolving functions, and the value also knows, like, I can be a promise resolving function. That's an interesting value. Promise capability records, these are shared between modules and promises and so on and so forth. So either these need to be reference counted pointers, or it's yet another heap vector. And now the items then, of course, have this index into this heap vector. Of course, that's what we choose. And each exotic object, each different kind of object we add to the engine requires its own implementation of the internal methods, because the backing object is going to be, or the heap data is going to look a little different each time, so it needs to be a different function. So this is actually kind of a very bad thing in a way, because code is also data. Although we kind of get some benefit from having very monomorphic functions, we do have a lot of them, and it, you kind of you're polluting your cache, instruction cache with that. So we don't have inheritance. The heap data access is always different. So the implementations, they all look really similar, but they're different. And of course, the GC really remains to be proven. Half space copying GCs are a thing, so I'm not really too worried about this. I think this is going to work, but it could also be that it just does not. And of course, as the heap size grows, then this just gets worse and worse. But of course, that's the thing for every GC. Yeah. That's the official part. I also have bonus slides if nobody has questions. But now, QA. And also, if there's more interest in the topic of like data-oriented design or JavaScript engine or Nova, we can also organize an informal or explicit breakout session later on the week.
All right. Great talk. Do we have questions?
Hi, I'm curious about how much performance benchmarking you've done and what kind of benchmark suites you've used for that.
Well, absolutely none. So I'll actually show this. So this is where we're at currently. We have about 3% of test 262 passing. Six. We've doubled.
Yeah, so the parser actually uses OXC, which is like the parser for a transpiler. And that means that a lot of the test 262 tests we get passing by default. It also means that we have over 60% crashes because we get an AST that we then can't use because we don't implement a lot of it.
Yeah.
So yeah.
Yeah. So this is like active development and more like let's see if any of this makes any sense. The more like as I was saying about the like 200 nanoseconds and so on. That's just the like ballpark estimate of what a cache line read, cold cache line read requires. Yeah. There are questions here at least.
Hi. I was wondering about objects that have many references. Probably not a very unusual case in a code phase that you have some singleton or semi-singleton that might be referenced by, I don't know, maybe tens of thousands of places just because the coders are using a framework, and it's somewhere in the class hierarchy, so it's always there. Those kinds of objects pose a problem for the little defragmentation algorithm you had proposed, and I assume that the current mitigation is that those objects could soon be promoted to the old heap.
So there is actually there is no separation between old and new. I was actually kind of theorizing that if you find that you're not collecting enough stuff, you're also not kind of creating too much garbage. You can actually just lower your new space index because everything is in the same vector, and now you just have like every object or every backing object is in the same vector, and now this index here says anything here is new, anything here is old. Now if you have a let's say you create a class that is then used very frequently, and it basically stays alive until the end of the program. Now it will slowly start moving towards the old space side. But yeah, like that's kind of a problem, but also, well, we'll see. Yeah.
Garbage collection is not my area, but I don't know. That sounds like it could very much be a problem when you run it on an application that has a lot of data, like those that were visualizing data earlier. Those can get ginormous heaps. And if you only have one heap and you have to move everything, I don't know, that to me is concerning, because yes, it might be an embarrassingly parallel problem, but you might still have to do it over 8 gigabytes of data.
Yeah. It's definitely a possibility that it ends up being like kind of totally unworkable. Then the mitigation would maybe be that if at all you can do it, then you will, instead of doing a major GC, you will slowly just take more, you will lower your index. So you're constantly doing parallel minor GCs. You do have a stop the world at the end, but you're never GCing the whole heap. You're GCing the top part, and then you move down a bit. You GC this part, and so on and so forth. Kind of staggered.
I was thinking much simpler things, like having some kind of virtual index, so that you can have things working with some small table in some cases without having to do a full defrag. I don't know.
We'll see.
We'll see. I'm curious how it will go.
I saw one more hand.
I have 2 questions, if I may.
Yeah.
One is, have you thought about giving this talk to TC39?
Well, I am in Finland next week, so I could, but not particularly, no.
I think there's even still space on the agenda. Second question, so you mentioned no embedder slots. I imagine that embedding is not a big concern for you right now.
Yeah, nothing is really a big concern. Another bonus slide.
Oh.
Here's our order of importance. We've done the first part. I am slightly interested. In Valmet, we do a lot of embedding stuff there, and we do have some possible use cases for a simpler JavaScript engine. Embeddable JavaScript engine that can be kind of feature flagged to drop out all the unnecessary complexity that you never use. And so embedded is kind of a thing, but embedder slots are still like, the engine currently has a kind of get out of jail free card where you can say you can create embedder objects, which are then, or you could if we implemented them, but that would be like the place where you go to when you need a special kind of object.
Okay, so if I was an embedder, like I would create one of these objects that would live in its own heap vector, and then it would have like a weak map inside it for storing data? Or?
Yeah, something like that, or not really kind of fully fleshed out yet, but there's a heap vector for dynamic, like a vtable plus the data, or actually vtable plus the pointer to the data of this embedder object.
Okay.
and yeah, you would then get kind of you could do your own object as you want it, have all the internal slots you want, and so on.
Okay.
And of course have the own internal methods for get, set, whatnot.
So while you were talking, I was trying to figure out how that might work, and like, would I be able to, like, if I didn't want to use this escape hatch, would I be able to get like my own vectors eventually?
I've been thinking about that, and currently what really blocks that, first and foremost, is that Rust, this is written in Rust, Rust doesn't have dynamic number of generic arguments. So it would be kind of really cool if I could say to the, or if you as an embedder could say to the engine, I will have 10 different embedder objects. These are the types for them, or the traits for, types for them. And now the engine would create those 10 vectors. That would be really cool, and it's possible to do, but it would require some annoying macro things, and basically just like pumping out implementations for 1, 2, 3, 4, 5, so on and so forth, different object types.
Cool.
Nice, thank you, Aapo. It's lunchtime now.
Oh.
So we will resume after lunch. And if you have questions, please feel free to reach out to Aapo later.
Hi. Let's get started. All right, so hello everyone. Are you still here? No. Yeah, back after the lunch. Next up, we have a talk by Stephanie. Stephanie is a designer and a project manager with over 14 years of experience. She specializes in developer experience and tooling, as well as the web platform. She is a proud pet parent of Vogue, who is a pom and is adorable. And together they have moved from Seattle all the way to England. Also, she's written a book called Design for Developers, which I think a few of us could really use. And now a PM at the web platform team. She loves mountain biking in her free time. Without any further ado, please welcome Stephanie.
Thanks, everyone. I have the dreaded after lunch spot, so it's my job to try and keep you awake. So yes, I'm a PM at Igalia, but my career has definitely been like living in the intersection of visual and UX design. I dabble in code and user research. I spent about 6 years on the Microsoft Edge team working on developer experience in the web platform. So some of the things I'm going to say today are based off of that experience and what I saw. I would like to give a quick shout out to Brian Cardell and Eric Meyer, because a big chunk of this talk is based off an outline and a discussion that they had back in March of this year during W3C breakout sessions. So with that, today we're going to dive into a very large and complex problem and talk about funding the web ecosystem for the future and how we can do so in a sustainable manner. So to start, I want you to imagine an ecosystem that provides a resource that is capable of generating massive amounts of wealth. People are constantly seeking this resource because of both the wealth it can provide and help create, and also because of its beneficial properties to humans. It provides tens of billions of dollars, and it enriches those who control it. And instead of pouring the profits back into the ecosystem and into the infrastructure of this place where great wealth comes from, it instead goes on to fund other things and make corporations richer. Now, some of you might be thinking, like, why is she basically giving us a high-level overview of the subplot for Dune? And what does that have to do with the web platform? So if you're unfamiliar with Dune, there's a substance and resource called Spice, and it basically formed an essential block of commerce and technological development in the known universe in that story. So they say he who controls the spice controls the universe, but I'm not talking about Spice, obviously. I'm talking about browsers and access to information. He who controls the browser controls the universe. And I don't think this is such a wild statement. We live in the information age that started in 1970. And the sub-period of that, right now, is the internet age. And information is the spice of our world, and our access to seemingly never-ending supplies of information is gatekept through web browsers. And browsers are critical infrastructure to life as we know it. And they're also extremely complex to maintain and keep healthy. There are over 5 billion internet users every single day, and that is over 67% of the global population. And they use browsers, which are free to do so. Now, this happens thanks to search royalties that fund browsers, kind of like an unofficial tax. It makes sense to use search for this because search engines get most of their value from the web, so paying back helps keep the web thriving. However, this creates a system and a cycle that has very many problems with it. So it pays for browsers, not engines. Smaller browsers don't get a cut of the deal, so the process to get a cut of the money is super unclear, and lots of smaller browsers miss out on that. So really don't know how to get a seat at the table. Ad and search revenue doesn't all go back to web infrastructure. Again, I used to work on the Microsoft Edge team. That Bing revenue was not coming back to our team, at least not the platform team. There were so many opportunities there could have been so many opportunities to fund so much more work on the platform, but we just didn't get enough of a slice of that Bing revenue. There's also legal and regulatory pressure. And then for me, they're owned by corporations. Like, this is a somewhat horrifying reality. They're owned by large corporations. And why is that horrifying? Why am I using that term? Well, I tend to be an overthinker and a very anxious person. I like to ask big questions like, what if? And when I was looking at what it means for a corporation to own something, my intrusive thoughts asked, what happens if those corporations disappear? So if we look at the Chromium project, which is open source, who do you think does the primary maintenance of the browser, of Chromium? It's Google. Overwhelmingly, they contribute the most amounts to Chromium every year. But when we look at how many browsers that we have that are based on Chromium, they are only providing a fraction of the work that Google is doing to maintain Chromium. So that's a lot of browsers, depending on Google, to just keep maintaining. So what happens again, worst case scenario, if Google disappears? $1 million question. And you might say, hold up, you just said it's open source. It's not going to disappear. But just because something is open source doesn't mean it has the foundations to remain a stable and viable option. Open source doesn't really solve anything when there are cracks in the system that are already starting to show and being reported on. Google had 105,000 commits out of 110,000 total last year. Who is going to be paying for the very large void that would be left if Google disappeared? So open source needs sustainable funding, which it doesn't have, and the web ecosystem doesn't have a sustainable system in place to keep it going. Our current digital infrastructure is dependent on a system that is designed to take and take and take from what already exists without contributing back an amount that ensures that the future is stable. So what is our current system? We have a company with a web engine and a browser, and then they have a search engine to access information, aka Earth's spice. And when you search, you're overwhelmed with ads in your search results. If you click on those, someone gets paid. Typically, those ads bring in billions of dollars, to the point that some companies with their own browser will pay other companies with browsers to use their search engine in their competitor's browser because they want that search, they want that money. So the company gets money, and ideally, you'd think you'd have a nice, even split of where the money goes back into the company, and then hopefully a lot of it goes back into the web engine. But in reality, that is not that's not what's happening. Web engines are getting just a trickle of money from the search revenue that only exists because of the web engine. And then the other aspect of this is the company that owns the browser and the web engine is going to push for features that benefit their company to be prioritized over the greater web development community's wants and needs. So they also steer the direction of the platform and the ecosystem. And I have seen this firsthand. Typically, features that help drive up revenue are going to be prioritized over what's for the greater web development community's good. So the system to fund the web is currently broken and under a lot of pressure. It's just not sustainable the way it is. So how are we going to fix this? It's going to be really hard because how do you get people to care about a problem that doesn't seem to be affecting them right this instant? I have another sci-fi reference for you. If you've seen the Netflix adaptation of Three Body Problem, how do you get people to care about something that will happen when they're long dead? It's really hard. And so I want to say this isn't going to be solved today or tomorrow or even next week. Like, this is a huge conversation and undertaking to try and reform the system. So the goal of this is to start conversations now, to start thinking about things before the system collapses, because it's less catastrophic to fix things before it does. And again, you might be thinking, Steph, you're sounding a lot like a doomer when it comes to the internet and access to the web, talking about collapse and catastrophe. But am I really? It's very hard to go throughout my day without relying on access to the web. I use the web, I use a browser for everything. Accessing my bank to pay my bills. My job is entirely dependent on the web platform. I mean, when was the last time you used a physical phone book to look up a company's phone number or address? Who has used a paper map recently? What would happen if everyone lost access to their browser right now? What would that mean? So, what do we need? We need money. If we're just going to be blunt, the ecosystem needs money to ensure that our foundations for the web are continually being improved and stabilized on, and that we're not relying on large corporations to be the gatekeepers of the web with their browsers. So how do we get it, and how do we encourage the contribution of it? There's just a couple ideas. There's going to be a lot more that you guys may have, but these are just a couple to get the conversation going. So donation-based systems that are voluntary or culture-based. So like if you're familiar with Open Collective, it could be something like that. We could provide incentives for donating or working on web infrastructure like tax breaks so that there's some tangible benefit to contributing your time. There's this idea of retroactive public goods funding, and this delivers incentives to public goods projects based on current impact rather than anticipated future work. So for example, not startup culture where you get VC funding and you get funded with the expectation that your company is going to succeed and you'll get a return on your investment. This is about investing on actual impact. We could even try and fix the current search and browser system to be a more effective tax that funds the work. And there are so many other ways that could potentially provide revenue to finance the web. And I mean, many more. Like, who wouldn't want to pay to watch merge conflicts get resolved live? Like, this is an aptly timed comic that came across my Mastodon feed the other day. So it demonstrates the problem that not just the web ecosystem, but open source is facing. Like, how do we get funding? So this is the problem that we need to solve. So if we do try and reform the existing system, it needs to be mandatory. So we could start by using the opportunity given to us by the EU, stepping in by lawsuits relating to search defaults or other such interventions to include this as part of the remedy. Another option is to get engines to introduce license terms that require participation from all parties that rely on their code. And then additionally, like, we could use browser choice screens as leverage. So by restricting whether or not a browser shows up on those screens when you have to pick, what do I want to open this in? Because there are so many companies that do have the means to contribute in a very, very meaningful way, but they don't. And this is ultimately putting strain on the ecosystem. If everyone continues to take and take and take from the well, the flow of meaningful commits back into Engines becomes a trickle compared to what they could be. And again, this just isn't sustainable. So if we want to fix this, first off, we're going to need a way to govern it all. We need a power structure that's credible, especially if you're trying to get donations from people. People want to know where their money's going. It needs to be accountable and be able to represent multiple interests. And we need governance that puts power back in the hands of the wider web community, not corporations. We know that there is a ton of collective experience in the group, in the community, in different standard spaces, and just, again, the general web development community. So it's not like we're starting from scratch. Like, the experience is there. We can make this happen. And then, along with governance, there's allocation. How are we going to distribute the funds? We could have small funds for each work stream, so people pay into the funds they want to. So this is kind of like the open prioritization initiative that happened a couple years ago. You could have one big fund and then democratize that process through votes. We could also use telemetry to detect usage and distribute appropriately. So this is a product manager's dream. This is data-driven funding. We could also use impact evaluators, or things like hypercerts that award based on positive impact. So hypercerts are a new token standard for rewarding and funding positive impact. And again, there are probably more ways to allocate funds that we're not even thinking about. So as with this entire conversation, anything is possible, and we need to start somewhere. So let's start today. Our digital infrastructure should be solid and secure so that the future of the web can flourish and thrive. It's a huge undertaking. This isn't a small ask, with many, many, many possible paths. And like I said, this isn't going to be fixed today, but we need to start somewhere. So let's keep it going. Here are just a few resources to start the conversation. I will leave this up if you'd like to snap a photo so that you can participate. But let's ensure that we're building a new system that can outlive us and sustain itself well into the future, so that the information, just like the spice, can flow. Thank you. I have a question for the group, because we have breakout session time available. Would anyone be interested in this becoming a breakout session for discussion? Okay.
Again, can you show me your hands?
Oh, no. That was just to see if people were interested in a breakout session tomorrow.
Naive, but as a concrete example, I love Servo, and I don't really have a clear idea about how Servo is being funded. Mm-hmm. I understand that Servo is hosted at the Linux Foundation, and I also understand that the Linux Foundation has a lot of money. Some of the Linux Foundation members are paying $500,000 annually, mm-hmm. and they're paying for something, but it's very unclear to me what they're paying for, what value they see there. And it's unclear to me where the money is going. They have a lot of money coming in, but looking around these days, that seems like a place where they've been somewhat successful at figuring out how to get money coming in.
Mm-hmm.
It's less clear, like I said, where it's going out to. But I can say from talking to, I work for W3C, and part of my work is trying to get companies to join and pay W3C fees to, what we charge for a membership fee. And some of the feedback I get is they're not interested in funding standards work. They want other people to do that work and pay the money to participate in working on it. But they are very interested, and they do have budgets for funding open source. And so they're looking, actually, the companies in Japan at least, looking for opportunities to spend that money. And so that's a good thing. But yeah, I don't know how much insight you have into that in particular about Servo and Linux Foundation. But
I'm going to let Rego answer that, because I have just a very vague sense.
Yeah, I can try to answer that. In the case of Servo, the funding is from external companies. It's not from Linux Foundation directly. So basically, yeah, Linux Foundation is like hosting the project and being an umbrella for the project, but it's not like providing funding for the Servo project at this point. I don't know if that was the case. Ever there was a small, like Linux Foundation projects can have a board and can have companies putting money there. But Servo is not that kind of project, doesn't have a board and doesn't have companies sponsoring the project. So for projects that are in Linux Foundation, that companies set up this board and put money, they, I guess, get some money from them. I don't know how that works exactly, but yeah, it's not the case for Servo.
Any more questions?
Thanks, that was a great talk. Excited to talk more about it. One of the questions that I had was whether you knew of any corollaries where any similar industry or similar pattern like this in other industries. Like, are there other things that we could point at where that greater good was funded by everybody who is able to extract value from that well?
Off the top of my head, I don't know, but Brian, do you know? Well, okay.
So let me narrow the scope a little then. In technology, as opposed to physical infrastructure, or like tech, yes, existing taxation systems are probably an easy example.
No, somebody back there was saying something.
I was just throwing out the words. I was just saying, like, GPS and GLONASS, and like they seem to be, I don't know any details about that, but they're like giant infrastructures that are funded by governments, I guess. That's all I had.
So for better or worse, related to what you're saying, an alternate funding structure besides corporations is like these GPS systems, militaries. And actually, they are funding increasingly open source software development when it's kind of security oriented. There's a lot of interest now in like open source supply chain security that's, driven in this direction. I wish we had another answer that's more along the lines of what you're suggesting, but at the same time, as long as it's being used for good things, maybe it's okay. I'm not sure. I also separately wanted to ask, given that there are many different kinds of software infrastructure that we all depend on, there's web browsers, but there's lots of other things like XZ was the big thing everyone was talking about. You mentioned governance structure. How should the world prioritize which things to work on and distribute among all those work streams?
Well, let me go back to my governance slide. I think it's really gonna depend on the people that we allocate to govern things, and then if we wanna have a democratic process, it can be through, then it goes into the allocation thing, like you can have people choose the work stream they want to, and that's pretty easy. Like, for example, MathML, someone pays for that, and it's like, okay, we are going to work on that because we had that funded. But then you sort of get into, again, like one big fund, well, voting to make sure everyone sort of gets a voice. And then trying to use data, or like the impact evaluator and HyperCert, which I didn't really know much about HyperCerts, well, I still don't, but just like what I have researched. But those are interesting because the concept of like rewarding work that we know is going to benefit the greater good is not something that I've really seen before. So I really like those models, but then it becomes like, how do you choose which of those things gets that funding? But it's a conversation starter. I don't have a answer, but it's a good conversation to have.
I have I guess, more of a comment than a question, which is, like, I think it is a really interesting question. I also don't think it is in any way specific to open source. I think actually the question that you have posed us here is like, what should our economic system be? Should we overthrow capitalism? And you know, I'm all for it, but I think it's a difficult question, right? And it's one that our society has been struggling with since approximately the 70s, when we decided to go towards capitalist society, and that we haven't really come up with a better solution yet. But yeah, I guess I would recommend to anyone who is interested in this to go and study economics.
I'm going to make another, I think I have a moment to make a comment, like just about funding things. I know that individuals will pay for things that they want. There was just a web component design system that raised $750,000 to like help this team build this system. Like that's a lot of money that they raised very quickly for essentially a design system. And I think there's this interesting problem that I again brought up, like people want to pay for something that is immediately going to solve their problems. So how do we sort of switch the narrative to talk about and get people to donate for things that they may not see an immediate impact or return, but is going to fund and like stuff for humanity and the greater good in the long term? And how do we switch that conversation and get people to donate for that? So,
any more questions? Okay. Well, I could ask a question as well.
Yep.
Talking about funding in like sort of fundraising in software, I feel that web browsers are so important and incredibly complex, right? Why do you think it's harder to fundraise for a web browser than it is for a video game or something that maybe is not as complex?
That's a really good question, and I don't know that I have a good answer, but I've never thought about it in that context. Because a web browser also provides entertainment, like it's how you get access to YouTube and streaming platforms, and part of me wonders if people have just sort of taken the internet for granted, like you've never had to pay for it. You get your computer with your operating system, and well, you've got Edge automatically installed, or you've got Safari, and it's there. Yeah. Brian?
So I think Stephanie's answer is like the essence of it is correct, except for you do pay for it, right? I mean, Microsoft is not giving you Windows for free.
Correct.
Right? Like they're making money, lots of money. So that, I mean, I think that's the answer, is that we have managed to trick everyone into thinking that it's free. right? It's like, I use this example all the time. Like my grandmother, when I was a little kid, cable TV came out, and we got like HBO, like, you know, commercial free, you know, and my grandmother was like, I can't believe somebody would pay money for a TV. It's free. Like, it's free. It just comes over the air. But of course, like if you watch commercial TV, it's not free, right? Like they're paying for your eyeballs, you know? And if you look at the money that comes into the web platform through search today, like everything is funded by tiny, tiny, tiny crumbs of that revenue. Like there's so much money generated by the web platform. So yeah, I mean, I think it's because we've managed to convince everyone that it's free by making them the product, you know? Yeah. And we've also sort of told this story that, you know, isn't completely untrue. I mean, Microsoft, Mozilla, Apple, Google, they have been like the champions of the web in a way, but, you know, also not because they're like the Avengers or something, you know? Like it's, you know, there's real reasons why they do it, and they're business reasons too. Maybe not the people that we know who are involved, that's not their motives, but, you know, that's what funds the work, so.
Yep.
Thank you. Well, any more questions? No? Well, thank you very much, Stephanie, for your talk.
Thank you.
Now, do we have a break? Do we have a break? Okay, next talk. Okay. On with his stuff, and today he's going to tell us about WebGPU and Deno. So please invite me in, welcoming on stage. He's already here, Leo.
Thank you. So today I'll be talking about the history of WebGPU and Deno. It's more complicated than one might think. So I'm Leo. I do web developer stuff. I'm software engineer, web APIs, and documentation related stuff at Deno. So what are WebGPU and WGPU? I'll get into details right now. WebGPU is a successor to WebGL API and provides a lower level API compared to it. It's more nitty-gritty, more similar to Vulkan, if you're familiar with that. WebGPU was originally proposed by Apple in 2017. However, the API, as it is now, does not really have anything to do with that much anymore with the original proposal. But after Apple proposed the WebGPU API, Mozilla proposed Obsidian, an interesting name, and Google proposed NXT. I'm not sure who's coming up with these names, but the WebGPU name was the winner. Well, but the community group further discussed APIs, and in the end, it was a bit of a merger of the 3 different proposals into what now is the API that is known. And during this talk, I'll also be mentioning WGPU a lot. WGPU is Mozilla's implementation of the WebGPU specification. A big part of WGPU's history is Dmitry Malush, Quark, had an idea of unifying all GPU APIs under a single abstraction and iterated towards it, starting with the GFX Rust crate, which was designed to work on top of DX11 and OpenGL. Then a follow-up iteration was built on more modern APIs, DX12, Metal, and Vulkan, which implemented a Vulkan-style API on top. So you could use the different systems only using a single unified API that was similar to Vulkan. And then there was a final 3rd iteration, which is WGPU, which is the crate that's used today. Yeah. Now some Deno internal structure. Since I'll be speaking about WebGPU in Deno, you might need to know some of how the internals of Deno work. The common understanding of technology Deno is split into multiple building blocks, but everything starts at Rust V8, which is just an abstraction. It's Rust bindings to V8 directly. On top of that layer, we have Deno core, which is a bunch of utility functions and other structs around V8 that make things more Rust-like and simpler to use, such as creating a JS runtime, generating snapshots, and having Rust functions that can be called into JavaScript, which we call ops, which will be relevant later, and a bunch of other capabilities are added on top as well. Then we have the extensions layer, which is different building blocks that implement various different APIs, for example, the Fetch API, Crypto, and WebGPU. Extensions contain both native code and JavaScript code, which the JavaScript code is what we use to define the web API's interfaces. And for the WebGPU extension, the JavaScript part is quite extensive since the API surface is quite large, about 205 kilobytes, which will be quite important later on. After that comes the runtime. The runtime is just glue code that puts all these different components together and adds some additional web APIs like Worker and some other functionality. Here's also where APIs are assigned to globals, etc. Finally, we have the CLI layer. It's just where various subcommands, etc., JS APIs related to those subcommands like testing and benchmarking are implemented and live. And that's the simplified version of the Deno's structure of internals. So how did how did implementing WebGPU start out? I started implementing it, the specification in October 2020, more or less. And the initial main effort was basically 2 weeks of mainly sleepless nights. And no, these are not the working conditions of Deno. That's just my insanity. While I was not working on Deno yet, was just doing this as an open source contribution. Most of the implementation involves just creating bindings to Rust and WGPU crate, but which is, again, Mozilla's WebGPU implementation. Everything afterwards was a lot slower and just fixing bugs, iterating on various smaller issues, and aligning closer to the specification itself, which was done together with Luca. We came across multiple issues, but thankfully Quark, who at the time still worked at Mozilla, was able to answer a lot of different questions and help us out to finishing up the implementation and a first pass of it in March 2021. But if that was all there is to it, then I wouldn't be giving this talk. Because additionally, we are also a bit more involved with WGPU itself nowadays. There's currently a bit of complexity that since November 2021, the source code of Deno's implementation lives both in the Deno repo, but also in the WGPU repo as a shallow clone. and which is not ideal. This is due to WGPU folks needing to have the source code as well because they want to use it to run the CTS, the conformance test suite, for WebGPU. And we cannot have like a shared implementation because WGPU needs a version of their own, so they can use the latest version of the WGPU crate and iterate on it on the extension implementation, while we have our own Deno core crate, etc., that also needs to be always on the latest version, and having a common place would just make iteration for both parties too slow. So we have this shared code base, well, not shared code base, but split code base where there's slight misalignments of the implementation that every month, more or less, I go and line up again, which is not ideal. So having some solution around that would be ideal, but we have not found anything viable yet. And since September 2023, so last year, Deno also is part of all the WGPU and overall administration team in discussions around those. So what's the problem then? Well, we will continuously keep the implementation up to date. The size and the startup time for Deno increased by a lot. Well, and also complexity. But complexity was something that was bound to be the case. WebGPU is quite a big API. It's not something simple. The size and startup time became a major issue, which led us to having to completely remove the API for a lengthy period of more than half a year. We had to remove the implementation in March 2023 after multiple discussions and back and forth with the community, which in the end the community was not really happy about it, but we had to do it. The main two issues were that the main issue was due to size increase and increase of the JF snapshot size, which was a partial reason for the large increase of startup time for up to 5 milliseconds, so from 14 to 19 at the time. And the binary size increase itself was not really too much of a concern, as it isn't that big of an increase by itself. So what do we do about the issue? Well, there were two main causes. The first one was macOS specific. On macOS, WGPU and its dependency includes various frameworks like Metal framework that are dynamically linked on startup, which are increasing the startup time a fair amount. The second more complicated issue is that the snapshot size increased by a lot. Deno uses V8 snapshots under the hood for faster startup time. However, due to the amount of JS code added by WebGPU, again 205 kilobytes, the size increase of the snapshot increased significantly, that it affected startup time dramatically as well. So, macOS static framework. One large issue for macOS was the linking of the frameworks. So WGPU depends on multiple frameworks like Metal and some other graphic-related frameworks, and it pulls them in that are required, and which increases the startup time for all users, even the ones that don't care about using WebGPU. It's still a relatively niche API. And we thought that there was no way to force these frameworks to be weak without a nightly Rust feature. But and in Deno, we don't want to build with nightly Rust. Just it's a decision we made. It avoids us headaches in the future. So we ended up patching dependencies and adding an optional flag in dependencies that is a link feature, which is enabled by default, and if disabled, it would not statically link these frameworks. But later on, we found out that this was completely unnecessary, and we ended up patching up those dependencies again to not need having those patches. So that more or less increased the startup time by 0.5 milliseconds, which is not that much of an improvement, but every bit counts in the end, about 3%. The other issue is snapshot size increase, which is quite problematic, and we were not sure what the best solution around this was, which is why we went the route of completely removing it for half a year. So we had some APIs that weren't part of the snapshot, so we were thinking that maybe we can do it like that. But however, these APIs that were defined on a higher layer of the Deno CLI, so on the CLI layer from earlier, but web APIs are on a much lower level on the extension level, which is problematic to not have there because we define the globals in the runtime level, so we cannot implement that on a higher level necessarily without causing potential issues. So we came up with a solution. Have ES modules that are lazy loadable internally. We have an internal struct called a module map in the Deno core crate that contains various things like the module loader, the pending evaluations, and most importantly to us, data about modules in the current execution. The data mainly contains things like handles to the loaded modules, information about set modules. Here we added a hash map keyed by the name of the lazy loadable module, if we want to call it like that, and that's by the name, and value is the source code of that module. And then this data is stored in the data section of the snapshot. To load these modules, we added an internal JavaScript API that we call createLazyLoader that accepts a specific specifier, which needs to be a valid loadable specifier, and returns a function that, when called, loads the module. Once loaded, the value is stored, and calling the lazy loader again does not reload the module every time, just one-time thing. And then instead of using a static import, defining the APIs like we do for non-lazy loadable APIs, we create a lazy loader and then call it in the navigation.gpu getter. And then we change the globally defined interfaces to WebGPU to also be getters instead of just purely properties that are defined on the globals, like usually web APIs we are, at least in Deno. And those also then called the lazy loader. The one drawback to do this initialization of lazy loader module isn't as fast, since the change we did is akin to changing from a static import to a dynamic import and just instantly calling await on it. But since the user base for WebGPU is so small, and I would say maybe less than 1%, even way smaller than that, of Deno, the few people can afford the trade-offs for one-time small expense, which I think is relatively viable. And after all these following changes, we introduced WebGPU in Deno in December last year without increasing startup time at all. And yeah, so what's next for Deno and WebGPU? Well, weak linking frameworks still loads them up. However, it doesn't initialize them. This is being worked on, and when we land it, it will save about 2 milliseconds up to 8 milliseconds across macOS versions, taking startup time down to 13 milliseconds for Deno. We also need to enable the WebGPU CTS. We have the runner, but it's not being run yet due to various complications. And after recently adding support for APIs like image data and image bitmap, the next step is implementing off-screen cameras in Deno, which I'm currently undertaking and is nearly complete. Following that, we'll be also looking into supporting canvas rendering context-2D through Velo, with whom we have been in discussions since a few months. And since Servo is also considering to use Velo for the same exact use case, there is a shared interest, and potentially there can be some collaborative effort to address any issues with Velo that come up, and with a common abstraction layer if necessary. And that's it. Thank you for listening, and yeah.
Do you have any questions?
Yeah, have you been following the like lazy modules proposal in T39, and do you know how much your lazy SM is similar to that?
I have not been following that. I'm not really familiar with that aspect, but it's more of just how we define APIs internally. It's not too much related to that, I believe. I'm not entirely sure. But yeah, I wouldn't really be able, I've not looked into that proposal.
All right. Who's next? Any more questions?
I know you said the number of users of this, Deno users for WebGPU is quite small, but I can also imagine that they might be quite significant users. So do you have awareness of who is actually using it and depending on it and what they're doing with it?
It's the active people in the Discord. It's I would say like 10 people use WebGPU in Deno, which is not that many, honestly. But we are aware of them and their use cases. But a one-time payoff of startup time of WebGPU Extra, which is relatively insignificant. And most people that use WebGPU probably will use it for more extensive applications, like maybe window rendering, which we support, or some computing with machine learning. That's always going to be a single one-time cost at the beginning of your application when using the first time calling to the navigation, navigator.gpu accessor. So I don't think there is any concern even from them that much.
Right. More questions?
Have you checked the increased size part of the snapshot? Like, are they mostly functions code or objects?
It's mostly function code. I've not looked too deep into the snapshot size itself, but it was relatively. I mean, there was some different increase with just adding the lazy loaded at the end of the data part of the snapshot, but I did not really investigate too much into that since our main focus was trying to get rid of the general use case, and it increased startup time, and that was the main focus to achieve. Again, ending compile time of Deno did slightly increase compile size, but it was so minimal that it didn't really matter to us. It did, though, also increase memory usage to do the lazy loaded module, but it was a worth trade-off, we felt like, and not such a massive. I don't have exact numbers in my mind right now, but it was viable enough.
Any more questions? No. Well, thank you, Leo. start?
Yeah, I mean, I just wondered if we should wait until the advertised time, or do you want me to just start now?
Yeah, Rico, what do you say? Should we start or?
Is it on?
How long do you want me to go? I won't stop. Okay. Yeah, just take a breath. Hello, everyone. Can I bring your attention back, please? Yeah. Everyone's still there? Spiritually, mentally, in every single way. So next up, we invite Nico Burns. Nico is a serial maintainer, from what I've heard. They still on the run. They are the maintainer of Blessed RS, of Taffy, and more interestingly, of Servo and Blitz. And today they're gonna give this presentation about Blitz. So please welcome on stage Nico Burns.
Yeah, hi, I'm Nico. Yeah, I've been doing some work on Servo recently, but today I am here to talk about and to some extent announce to the world Blitz, which is a new web renderer. I've purposely not called it a web engine for reasons that we'll come to in a minute. But yes, and Blitz is a project of Deoxys Labs who are funding the work on this. So I just thought I would call them out because it's good that there's funding. Yes, and on that topic, just as a bit of context, I'm going to talk about Blitz in a minute, but Deoxys is Deoxys Labs' kind of primary, I guess you'd call it a product or a project. It's an open source project, and it is effectively like React or Vue or Angular or some web framework, but in Rust. And similar to React, like it has a DOM implementation, but in theory it could be agnostic, and you can have, you know, React has React Native, and it has React SVG, and it has React PDF. So it is a kind of generic state and like management library in that sense. It mostly renders to WASM. You can compile it to WebAssembly. You can actually get it to render a website in a regular browser. But it doesn't have something like React Native to render natively. And that's just a screenshot kind of showing the sort of code you might write, just to give you an idea. And it looks kind of like, maybe not quite like React, but like Svelte or whatever. Okay, now Blitz is, it's an HTML and CSS renderer. So it's basically a web view or a web engine, but it does not have a JavaScript engine. And the idea is that you can combine it with Deoxys or some other scripting engine in Rust, and then you can just completely bypass JavaScript, which is obviously more efficient, saves on binary size, etc. So this is targeting the kind of the application UI space, so kind of like Electron. Primarily, it could potentially be used to build a full browser, but that's not really the use case. I think if you want a browser, you just use Servo, which will share some of the components. And some other similar projects. So Skyter is this like UI library that's used by a lot of antivirus software for some reason. And is a similar kind of take on being a web-based UI framework that kind of renders vaguely standard web stuff. Ultralight is like, I think WebKit based, and it's for rendering UIs in game engines. And there's some other ones as well. We're building on a lot of servo components, particularly Stylo, the style system, which obviously is used in Gecko as well, and also a bunch of components that are from the kind of general Rust UI ecosystem. So we're trying to kind of combine different libraries that are out there rather than making everything proprietary to our kind of own thing. And we're also building some bits ourselves. And the idea is that it's going to be kind of really modular, and Servo bills itself as being modular, and it is, but also, like, you build Servo, it's a great big thing. You can't, you know, you can't cut out the video playback, for example, or you can't, you have to, you can embed it like you can embed Chromium, but you can't pick bits of it, and we really want to push on that. Partly because, like, a bit about what Steph was talking about earlier, like, I think if the code is usable individually, can be documented individually, then it can be a bit more sustainable, and you can get different parties that have different use cases investing it rather than it just being just for the browser. And if the browser's funding gets dropped, then it isn't going to get developed anymore. So our architecture is like this. At the bottom we have the core, and I realized that a lot of these words might not mean anything to you. So Stylo is the style system. It does CSS parsing, and it does selector resolution, and it does resolving of computed and used styles. Taffy does layout. It does flexbox and does CSS. It kind of does box level layout. It's not going to do text level or inline layout, which is what Parley does. It's doing rich text and also like inline block and things like that. Access Kit is an abstraction across the different platform accessibility APIs. And then we have some image processing libraries as well. And that is our core. And you'll notice what is not there is any kind of rendering to screen. There's no painting. So our idea is that you ought to be able to use this engine and bring your own renderer if you want to. If you want to render on, for example, an embedded platform, or you want to, if you are someone that already has a renderer and you just want to build web content in, then you can just use that bit. We also have a renderer that we have implemented, which is using Velo, which is a library on top of WGPU. And that blue, the darker blue there is trying to indicate that's the one that exists. And then these other ones are things that could be built that do not currently exist. So in theory, you know, you could have a web render backend or a Skia one, etc. But those things don't currently exist. And then at the top level, we have kind of two kind of entry points into the system, if that makes sense. So one of which is integrated with Dioxys. So it will, you know, the event system then is directly the event system in your kind of React-like library. And you don't have to go via a JavaScript layer or via any kind of abstraction, really. It just plugs straight in. And the other of which is a kind of an HTML engine. And I put Markdown on there as well, because obviously you can quite trivially compile Markdown to HTML. And we think there's a use case for this in being like a lightweight preview for HTML files or Markdown files. Yeah, I mentioned this to some extent already, but we kind of have a philosophy of really prioritizing modularity and extensibility and hackability over perhaps being like a completely correct implementation or the fastest implementation. We hope we'll get there, but that's not our priority. Our priority is to be a maintainable solution, a reusable solution, and to interoperate with different parts of the Rust UI ecosystem so that we can hopefully get lots of different stakeholders reusing the same piece of code. So we are trying to use different components from across the ecosystem. So we're using Stylo and the HTML5 ever parser from Servo. We're using Velo and Parley from Line Bender organization, and various other bits and pieces. And then we're also trying to make the code that we are writing ourselves, one of the main bits of which is the layout engine, available to use even if you don't want to use our engine, which I think is quite, and I mean, I may be corrected here because there's a lot of experts in the room, but my understanding is you can't do that with, say, the WebKit layout engine. You can get the whole of web core, but there's quite a lot to that. You can't just pull out the Flexbox implementation or the selector parsing implementation. So we want you to be able to turn off bits of our system. So if you want to ship an app, then you don't have to, and you're not rendering SVGs, then you don't have to ship all the SVG code, all the video rendering code, etc. But we also want you to be able to add bits that are not part of our base code base. So for example, web engines have special bits that you can't create in HTML, for example, form controls or video controls. And we're hoping, we haven't got this implemented yet, but we're hoping to provide an extension kind of API that allows you to do custom shaders to draw or add custom layout algorithms that are not part of standard CSS, which we think will be useful for experimentation, but also, if you're shipping an app and you're not trying to deploy it to the web, then you can ship this and you don't need to ask permission from anyone else or get it into the standard. So yeah, I talked about binary size. It is quite different to Servo, and I believe other web engines are most of them are around this kind of 100 megabyte mark. Maybe get it smaller if you do custom builds of things, but it's not very easy. And so yeah, we're quite a bit smaller. We're also not feature complete yet, so I would expect that 12 megabytes to go up a little bit, but I suspect it will, it's going to be more like 15, 20. It's not going to be 100. And I also just included this screenshot, which is from Cargo Bloat, which is kind of an analysis of Rust binaries to go, what is actually causing this binary size? Now, ignore the absolute numbers because it is not accurate, which you can tell because if you add up the numbers, they do not add up to the size of the binary. But if they were analyzed using the same method, so hopefully they are kind of proportionally comparable. And I just wanted to point out just how much of the binary size in Servo is the script and OzJS creates. It's by far the biggest thing. WebRender is also kind of big. But if you look, the biggest thing in Blitz is the stylo style crate by some way, and that's kind of way down the list on the binary size. So I think there's quite, a lot of benefit to this cutting out the scripting engine, basically. And of course, all the DOM APIs that go with that. What was I going to say? Sorry, I've forgotten. So I'm just going to go through kind of some of the libraries that we're using because people may not be familiar with them. So we're using Stylo from Servo Gecko, which is kind of quite incredible in what it provides with like a nice API that you can use independently of these browsers. You get CSS parsing, you get selector resolution, you get things like calc computation, it resolves all of the relative properties, everything, and it will do it on your own tree implementation, which is fantastic. It's really fast, it's multi-threaded, it's reliable. We've had some problems, but I think they're our own, which relates to this other point, which is that it's not very well documented. There's lots of methods in traits that I know we need to implement, but I do not know how to implement. Haven't worked it out yet. So one of the things that we're hoping to do as part of this project is to kind of improve the documentation, to get a regular release schedule out, to do kind of open source hygiene things. And hopefully that will, enable more people to take advantage of this great library. And And the other problem we've had is that if Servo doesn't support the feature, like, for example, CSS Grid, Servo doesn't have a CSS Grid implementation, then the passing of those styles is disabled in the kind of available Servo build of Stylo, which means we can't access them either. So we need to kind of come up with something for that. But we're in talks to kind of sort that out and to produce a build that does everything. For rendering, we have this Velo library, which it's a 2D renderer. It's quite an innovative one. It is on top of WGPU, so it's kind of using Vulkan and Metal and DirectX 12 rather than like OpenGL. And it's not only using those libraries, it's using compute shaders rather than the regular graphics pipeline, which enables with some very complex math, which goes well over my head, even though I studied maths at university, very fast rasterization of vector graphics. So I have a little video here, which is working excellent. So this might not look very impressive, but what this is actually doing is it is rendering the glyphs of these fonts at a different, the video stopped because it's just a short video, at a different size at 120 frames per second, which is better performance than you'll get. And maybe you could do it with this small number of glyphs with an existing renderer. But basically you can get much better performance. But we are kind of hedging our bets with the renderers because while it's quite impressive, it's also quite immature. But we, I guess, this is an example of us trying to take advantage of something that's out there, that's doing something cool, rather than building our own. I want to talk about what we're doing for text, because I think this is quite different to what a lot of engines do. We have a pure Rust stack, which is not using any of the system text APIs at all, apart from on some platforms, it's using it to enumerate fonts. So Screefer is being funded by the Chromium team, and it does font parsing and also hinting and scaling for kind of glyph rasterization. These other libraries, Fontique and Swash and Parley, are open source libraries as part of the Linebender project. Fontique does font enumeration and fallback. Swash does shaping and kind of miscellaneous analysis of Unicode text. And there is also RustyBuzz, which is basically just a Rust port of HalfBuzz, which we might be using for that. And then Parley is, in my opinion, the most interesting one, which does the text layout, and to which I have recently been working on adding the inline block, hence those black rectangles that are not very pretty. But obviously, if you are actually rendering, you can render those how you like, but it's the fact that it's computed the positions which is useful. So yes, I think the idea is to create a standalone library that will do all of the hard parts of text, basically, including the shaping and the layout and the rendering, that you can plug into anything that you want to. And currently it is, it's not going to have the full web feature set, but I think the idea is that it could. And it's worth mentioning that this is kind of different to what Servo does. It has its own layout engine, and I think we are open to kind of merging projects in some way. But a key thing for us is that the layout engine is usable independently. So we're kind of only going to do that if we can work out a way to extract the layout from Servo into an independently usable library. Yes, and I should just mention that we've put a bunch of work into the library. We haven't actually integrated the library. So currently, this over here is what a website with text looks like in our engine. And this is actual servo. So not good. And you can see that we don't have font fallback, hence a bunch of missing characters, and we also don't have any line wrapping whatsoever. But we have the library there that will do that we just haven't plugged in yet. So for the box level layout, we're using a library called Taffy, which is one of the things that I have personally worked on the most. It has a very good Flexbox and CSS grid implementation, where very good is at least as good as React Native, I would say. And we have 1,000 tests that show it's the same as Chrome, but 1,000 is not WPT's complete test suite. And we currently have a bit of a problem with running the WPT test suite because it assumes that you have a whole browser with a scripting engine. So there's a few ways which we can solve that, one of which would just be to add a scripting engine specifically for running the tests. I'm not particularly keen on doing that. I'm hoping that we can, for specifically layout tests, come to some kind of format for the tests that doesn't require script. I don't know if there's anyone in the room that does WPT tests, but if you are and you know how I can make this happen, then let me know. And I also have some contact with the people who do the yoga library that powers React Native, and I think they would also be interested in this because they currently use the same test suite that we do, but would like to have full kind of web compatibility. And yeah, I should just mention that the approach we're taking with this is kind of similar to the Ladybird web browser. We're like really trying to follow the spec in the structure of our code, which I would totally recommend to everyone because it makes it so easy to fix the bugs. You know, you still have to work out what it is that you've missed, but once you do, it works, and it seems to pass all the tests, which is great. And I guess I'd also say, currently it's not production grade from, you know, a tier 1 browser point of view, but I would like to make it so, and I don't see any reason why it couldn't become so. And I think there is the kind of potential in a kind of neat, well-maintained code base to really push what layout can do and like parallelize it. So if anyone is interested in kind of growing this project, then yeah, come and join. But yeah, just to kind of, I guess, illustrate where we are, this is Servo's 3 layout modes that it has. So on the left we have, I believe, Layout 2020 with Flexbox enabled. I think in the middle we have Layout 2020 with no Flexbox enabled. And here we have Layout 2013, which actually, for this particular page, which is obviously the Google homepage, seems to be the best, which I think is interesting, but hopefully that will get fixed at some point. And then this is Chrome on the right and Blitz on the left. So, I mean, you saw the screenshot earlier where, you know, our rendering was terrible with the text stuff because we've not really worked on that tool yet. But for the Flexbox and grid stuff, we are pretty good. Yeah. And hopefully we can push some of that into the Servo project as well. Yeah, if anyone is interested in kind of working with us, then let me know. And then, yeah, so I guess in terms of what we're planning to work on going forwards, getting the text stuff in is top priority. I was actually really hoping to get that done for today for this demo, but didn't happen. So I thought I would be honest and put the terrible screenshot in instead. Getting all the font loading working, both the system fonts and the web fonts. We currently don't have any kind of interactivity, like you cannot click this. So that is quite a high priority, and that brings with it quite a lot of complexity just in terms of dealing with updates to the DOM. Currently we run it once and then it's done. So I think that will require quite a lot of attention to make sure that it's working reliably. We want SVG support, which I'd be quite interested to see the talk later actually, because one of the interesting things about using Velo as the renderer is it has very good vector graphics support, so we should be able to just plug that straight in. There's a bunch of CSS features we don't quite support, And then, yeah, I think a big one will be allowing people to build custom widgets, which we can use ourselves to implement things like form controls. But we really want that to be almost like a proper UI toolkit rather than just kind of an internal one. And we're looking at some of the options in the Rust UI space to just plug in. So yeah, that's it. There's some links here. I don't know if those will be, I guess the slides will go around at some point. If you're interested in getting in touch, then do it. And yeah, if anyone has any questions, then please ask.
So folks, questions? Who's first?
Sorry, I wasn't listening as carefully as I should have to the part where you were talking about WPT and what you couldn't do in WPT and about lack of scripting. If you could explain that a little bit more.
Yeah, so I mean, the problem we have currently is that we cannot run the WPT at all because we do not have a JavaScript engine.
So it's when you say lack of, I misread that as lack of scripting support somehow in WPT, but it's the other way around. It's not a deficiency in WPT itself that we could fix in WPT. It's from the other side.
Well, I mean, in some ways it's WPT being too featureful in that a lot of the layout tests, which shouldn't really require scripting, happen to use scripting to, for example, generate DOM nodes to test the layout of, and then to kind of assert like whether the layout is correct. And not all of the tests do that. So some of them are just plain HTML, and there's like a reference HTML that you compare.
Right. So MS2GR mentioned that on the Matrix channel, that we do have the ref test mechanism, at least, which doesn't itself require scripting. You can write a ref test without
so the ref test kind of works for us. When I was just working on the Taffy library, that was also difficult because we didn't have a renderer either. And I do think that a new kind of test that just like compares actual like integer or float values for the dimensions of boxes would be good, partly because it's actually more accurate than a visual ref test, because there's multiple different ways in which you might produce the same visual result. But yeah, what I would also ideally like is just to kind of almost ban scripts in layout tests, and maybe turn it into a build script, or there's some other way to do that. Whether people can be convinced to accept that, I don't know.
So I know that sometimes in ref tests, script is used in order to test invalidation. Maybe you have some initial state and then you change it with script, and then you do you have a class that you like to make sure that that after you change that, that's when the snapshot gets taken. And so I wonder how Blitz does with like invalidation and those kinds of things.
So
I wonder, I assume you, like, how much do you optimize things, and do you run into invalidation issues?
So in Taffy, which is the layout library, we have had bugs from invalidation, and we've kind of written manual unit tests for those is currently our solution. I can definitely see why you would want to use script in that case. I think my kind of short-term suggestion would be, if that's the case, great, keep the script, like, that's fine. But if it's just a case of you can't be bothered to write out all the test cases, then that seems like it could be dealt with, some other way.
Thank you. Next question.
Behind you.
Hi. I was curious how you balance the complexity of allowing sort of maximum modularity with sort of like the combinatorial explosion that comes with that. Sort of like both in terms of testing and also managing the complexity throughout the code base.
Well, I mean, it does introduce complexity, and it certainly makes you think about your code a bit more, because you have to define. Doesn't necessarily have to be a stable interface, but it needs to be a kind of a clean interface with a boundary. I think, I don't know, I found that it makes each individual bit much easier to understand. And I mean, I've been working, primarily with the layout, and layout doesn't interact with an awful lot. Like, there is a reasonable amount of API surface, and it's almost entirely just a great big struct of styles. There's a lot of like styles having to go in, but otherwise it's just like a tree structure. And a lot of the servo libraries also do this, where they basically make you implement a trait that kind of walks through the tree. And we've done the same. And then, you're outputting a size, which is not, that complicated. I do think there are areas where it would be more difficult, and especially, we've cut out the scripting engine, and that's where, I look at servo and I'm like, how would you disentangle that? I think that would be very difficult. I would be interested to see someone put a scripting engine on top of Blitz, because that could be done. I don't know whether it could be done performantly or not. But yeah, interesting.
All right. The next question. No? All right. Thank you, Nico.
everyone. Hello. Let's prepare for the next talk. So for the next talk, we have Nikolas Zimmermann. He's an engineer working on WebKit for a long time, and I'm sure you're excited to hear about all of his great work in SVG, but I think it's important to highlight that Nikolas has been working on the web platform since as early as the 2000. And he started out working on KHTML, which forked to become WebKit, which, as you might know, eventually got forked to become Chromium. Another very important fact about him, however, is that he's an astrophysicist, and he specialized in astroparticle physics, so effectively moving from the building blocks of the universe to the building blocks of the web. Who knows which one's more important? But please, without any further ado, put your hand together for Nikolas.
Yeah, hi. Thank you for letting me talk here about the status of the LBSE. So you will hear that acronym more often. That is the layer-based SVG engine. So it already hints at that we're doing something different because the current SVG engine does not know the concept of layers. And I will talk you a bit about what that actually means and why it's problematic for WebKit. But let's first start with a short introduction so that the LBSE work overall has been a joint effort. So between me and my colleague Rob Buys. And fun fact is that we both actually started together this KDOM, KSVG stuff back in 2001. And now we unified and set again to finally fix the SVG engine that we were like partially responsible for. Especially its errors and design issues, which we are going to cover today. So first of all, let me give you a short introduction for those who do not know about LBSE at all. So that's the code name for the new SVG engine in WebKit, and it started basically as proof of concept in 2019. So it's already a while under development. And the goals that we have with it is not necessarily directly new features, better performance or whatever, but we want to fix some architectural issues that have been plaguing WebKit since like at least 15 years. Those who have tried to use foreign object and try to do something useful with it in WebKit will have seen its limits. So whenever you put in a, let's say, an absolute positioned diff element inside a foreign object, it started to render at the top left on your screen. So it was not like respecting anything related to layers in SVG. So that is like the most important architectural goal that we want to resolve, getting foreign object support properly working in WebKit. That requires a real re-architecture of the whole design. And that is why it has never been done so far, because it's a huge task and you basically, for the first years of doing this, you don't get any reward. Ideally, in the end, everything still works and a few more extra cases work. So it's a hell lot of engineering effort, but it needs to be done if we want to enable hardware-accelerated compositing, if we want to have hardware-accelerated and transform opacity animations within WebKit, if we want to have all the nifty features like 3D transform support, perspective transformations, stuff that's like since a decade available for HTML, CSS, but not for SVG, but it's like the graphic representation of the web, which cannot do these kind of things, and that's a pity. And we need to fix that. And for that, you need to know that WebKit historically has had two different kind of rendering pipelines, one for SVG and one for the rest. And where does that come from? So when we started integrating SVG into WebKit, there was no CSS transform module level 1 spec. There was no transformation support in CSS. There was no support for masking. There was only support for basic clipping, no filters, nothing. At that time, SVG was, we are talking about 2003, 2004, was quite advanced in terms of features. And if you then looked at WebKit, layout was still integer-based, so it had no concept of transformation, nothing. So in order to not break the existing content, to not make HTML slower, which needed none of these features back then, it was decided to really decouple these rendering pipelines and do something special for SVG. So whenever you have a SVG subtree that's painted differently than the others. And that has, that has manifested in the engine and still with us today. So we set up to unify these rendering pipelines and have only one source of bugs, basically. So if you have a bug that affects HTML, CSS, you will likely have it in SVG as well, instead of the situation we have right now where things work nicely in CSS land. You apply a same, let's say, a blur filter or something, a sepia filter to SVG, and you start to see bugs, and you wonder where they come from. And that is really because underlying the code paths that are taken are entirely different. So in October 21, the proof of concept patch for LBS that does all of these features was basically ready for the first time. It gave us a performance that was comparable to the legacy engine. So some subtests, for instance, in MotionMark were slower, some were much faster. However, all the new things that you can apply to SVG now, like compositing, support Z-index, will change. All the things that are unlocked with this were only tested in basic scenarios. And overall, MotionMark was slightly slower. 2 to 4% might not seem worrisome, but per the WebKit policy, we never ship any performance regression. So that is completely unacceptable for end users in the end. So we need to get that fixed. But I mean, this is only, these 2 to 4% is like representative for MotionMark. You find other cases where it's like 20 times faster, especially on embedded. When you try to animate anything with the legacy SVG engine on an embedded device, you will never see 60 FPS. Here you have the possibility, if you do it correctly, like not modify the layout, not modify, let's say, XY positions of circles, not causing any relayouting, but only sticking to CSS transform animations, you get it hardware accelerated because nothing is repainted, it's only recomposited. So that's like the key for embedded device performance, is to introduce this layer concept for us. So how did we achieve that? So that is really high level. So SVG needs to participate in this layer tree logic. So if you know about the layer tree and how it works in WebKit, so first of all, we have the DOM tree passed from the HTML or SVG source. From that, we built a rendering tree. And that rendering tree is not used for painting. We have another concept in WebKit that's so-called layer tree. And you can think about it, it's a paint ordered Z-index sorted view of the render tree. So in the end, what you want to paint, you need to traverse the layer tree and not the render tree. That is how it works for HTML, CSS. And there are certain conditions that trigger creation of layers. For instance, you transform an element, you put a filter on it, you put some advanced CSS properties. Many of them cause a layer to be transformed, to be created. So in HTML, CSS land, also this render tree does not know anything about transformations. But transformations in SVG are like the core of it. Every element can be transformed. That's used extensively as opposed in HTML, CSS land. So that was completely different handled in SVG all the time. That led to specific code for clipping, marker, masking, filters. And when this was introduced in CSS, it wasn't like unified or refactored. It was rewritten in a different code path for HTML, CSS. It was not easy to unify this. It has never been, so it wasn't done. So now we end up that we really need to redesign the whole SVG render tree to be convenient with the existing HTML, CSS tree. And of course, we want to reuse as much as code possible from the existing HTML, CSS implementation, which has features like hardware acceleration, compositing, which we do not have in the legacy SVG engine. So the final version of what we came up with in 2021 was a drop-in replacement for the old engine. It was like a 40 megabyte patch that removes all the old engine and puts in a new one. Ready. That's not how it works. You cannot get that into WebKit. That was clear to us in the beginning. That's why we are always talking about a proof of concept, demonstrating that we can do something useful with it. So we met with the WebKit stakeholders in 2021 and thought about how can we possibly integrate this LBSE into WebKit. And what we agreed on is we basically need to redo it in a way that it's no longer a drop-in replacement. So that means basically, it's nice, you've demoed that what you can do, but we have to really do it again in a way that we can at runtime switch the SVG engines. This was like the hard requirement from Apple's side. And in the end, it makes sense because we can always run our tests with the old engine and the new engine in parallel and do comparisons, A/B testing and all of that. So in the end, when we do the switch, if we go that route, we can be sure that we do not regress performance or do not regress any feature support. So upstreaming of that started in 2021, end of 2021, where we introduced like these compile time flags and additional settings. And from that on, slowly started to integrate our stuff into WebKit. So not to make this a historic exercise, I will now look fast forward a few years and see where we are right now. There's a bug report. I think it's 12 years old. I opened this like in 2020, 2012, that bug report with an initial patch to unify these rendering pipelines that was unfortunately not picked up when I left the WebKit world to pursue my PhD. And when I came back in 2019, when I joined Igalia, I was like very keen on to see what happened in changed in WebKit world, how much is SVG advanced by now? And the answer is 0. Nothing, like all the architectural problems are still there. Nobody has resolved them. So we have to do it. Otherwise, we are not going to see progress on that front. So since then, we have worked from, you can see the dates here, from 21 to now, upstream something like 160 patches. Some of these patches are like 20, 30 iteration patches, larger patches, so alone the patch count doesn't say much, but I can assure you all the core functionality that we need in order to support compositing, hardware acceleration, that's all already upstreamed. So the last round of progress in LBSE was due to funding from Wix. So if you do not know Wix, it's like a website builder platform where you can build your websites rapidly. And they are using SVG a lot for some kind of effects, logos, text, whatever. And they had a great interest in moving SVG forward, especially in WebKit, since it received much more attention in the other browser vendors. So Google invested a lot in SVG. They did fix many, many bugs that are still present in WebKit. And choose a different route to achieve like a faster SVG implementation. But for us, we made up the plan that we continue this work and try to really integrate the rendering pipelines in such a way that we end up with only one, which Chromium hasn't done. So the status back in October 23, when we presented this in a WebKit contributors meeting, was that LBSE had a lot of functionality related to compositing, hardware acceleration, but it could only render solid filled shapes and stroked and filled shapes, but no advanced SVG features. There was no clipping, no markers, no masks, no gradients, no patterns, no filters. So everything you expect from SVG was still missing. And that is because there was another architectural issue that we had to resolve, and it's all about the so-called resource invalidation logic. And I will talk a bit about what that is and why it was so important for us to resolve it. So first of all, what is a SVG resource? That's not a standard term, that's something I dubbed. So SVG has the concept of paint servers. These are these elements, linear gradient, radial gradients, and patterns that you can apply to fill in stroke of shapes and text. And in our jargon, we extend the term to all the paint servers plus clippers, masks, markers, and filters, and we call that resources. And I already said that the status of the resource support in October was with no support for anything advanced, only very basic fill and stroke operations. But that we tried to delay redesign, the re-implementation of the resources until we finally resolve the design issues that we had in the previous engine. To give you an example, the resource invalidation, that means reacting to the changes that you apply by script, is fundamentally broken in WebKit SVG land. So if you take that example document here on the left, you can see a simple snippet of a DOM tree. It has a clip path, which has a circle inside, has a mask, which has a rect inside, and that mask is applied to a path. But the mask child element, the rectangle itself, is clipped. So we have here a level of indirection. So we have the path object, if you look at the render tree, that uses the mask resource. The mask resource itself uses the clip resource. So you might ask yourself the question, what do we do if we change like the radius of that ellipse? How does WebKit react on it? It doesn't react as you would expect from first principles. It's quite complex. So when you by JavaScript change that SVG circle element, change its radius to 20. By nowadays, all these properties, the X, Y, ZX, ZY properties are, attributes of SVG, DOM attributes. They are now mapped into CSS properties. That has happened over the past years. So when we change such a thing, what we do is we update the presentational style for that element and trigger a style invalidation. So that's fine from now on. But what happens is when the renderer, in this case the render SVG ellipse, it does receive a new style, what it will say is I will need a relayout. Because that is, in regular world, if you have a document which has only a rectangle, you change something, you need to relayout. So we're using this very same mechanism here. That means when that ellipse is marked for layout, and we would only execute that operation, nothing would change because that ellipse is not visible on the screen. It's a part of the resource. It's only used indirectly. So as next thing, we then say, okay, we need to find all the users of that clipper resource and also invalidate them. That's the masker resource. Okay, and then the masker resource is used by the path. We also have to invalidate that. And that leads to like a chain of invalidations, and also not synchronously, because when we get a new style, we trigger a relayout, but that's asynchronously. So when we receive, like when we execute that update, after that, we have to relay out basically that whole document here just to accommodate for that radius change of the circle. And that's totally inefficient. What we actually want to do is we want to change that circle and then just repaint the path. That should be sufficient for anything. Layout shouldn't be involved in there. But historically, we made the mistake to reuse the very same mechanism for resource invalidations. And that has led to numerous bugs of security issues in the past, like circles that we didn't break properly, running to endless loops and whatever. Because in SVG, of course, you could add a third resource here that references the first again and create some cycles here. And you need to break them at some point. So I left some of the call traces here. If you're curious and want to see on your own how that works, I left some hints where you can on your own follow like the call frames, what actually happens when you try to play that example. I will leave that out here for this discussion and focus on that point above. The important one is actually triggering layout from within layout is evil. And we should not and cannot do that. Because it has led to, in the past, also to issues that after layout, the layout was still dirty. Because there were still some things dirty. So a second layout passed and fixed that. But you had frame delays. So when you looked at exact frame timings, when you expect, okay, there's a new frame that should have the update in, it didn't. The next had it in. So and people that were looking at really at frame by frame noticed these things. And that has been like always in WebKit. And to make things worse, the correctness of the invalidation chains depends on the element order in the DOM. And you can easily create problems when you just move around resources in the document. That shouldn't be possible because totally should not matter where in the document it's placed in SVG. And in principle, you can also place these resources in external documents and reference them. There you open the box of Pandora. I don't want to talk about that at all. Just the takeaway message is that's a real bug that's plaguing WebKit SVG and kills our invalidation performance. And we need to resolve that. Status in 2024, it's done. So we finally found an approach to redesign this resource invalidation logic that uses similar concepts from CSS, and it's no longer relying on layout. So we are communicating like these invalidation things differently, and all the issues that we had in the past due to that are gone. That's already upstream, and since that was upstreamed, like implementing the rest was a piece of cake, since we already had the knowledge how to do like clipping, masking, etc. from the old engine, and we basically just moved like the building blocks we already had into this new concept, married them, and finally we have all these features available. Like in like half a year ago, all these looked like unspectacular, solid build, no clipping, gradients, nothing. And by now we have like all the advanced features. I demoed some of them here, clipping on text and images on text and on fill and stroke, etc. Gradients on fill and stroke, patterns, clipping, masking, and recently filters. So what is still missing, you might wonder? Well, in the short term, like the most important thing for us at present is we need funding for this work. Because over the past 4 years, we didn't have continuous funding of this project. So while it's of real importance and provides value for the web platform as whole, if you think about Stephanie's talk, we don't get any big attention to this. So I was expecting like all the big companies giving us chunks of money to finish this work as quickly as possible so they could realize new devices, making use of SVG like extensively, because you could have access to something fast to make nice user interfaces on embedded. But really, we do need more partners. So if you have any idea about a funding source for this, please let us know. And then, of course, from the previous screenshot, what is not upstream yet is the filter support. So when we met in October last year, we talked with Apple about these plans, and they said, okay, we are going to take care of filters. Because we have, there's one guy working on SVG at Apple, and that guy happens to know the filter, Said from Apple knows the filters implementation very well, so he said he's going to take care of it, and he did. So that patch is under review at the moment. And that's really the last missing piece. Then we are feature complete in terms of SVG resources, and all these resources that you can see are applicable to all HTML, CSS, all HTML elements and SVG elements. So all mixing is possible, and it's running through the same code path. So if you see a bug on an HTML element, you have the same bug on the SVG element, and vice versa. So for the web author's perspective, it's much nicer now. If you have a bug, it's universal. It's no longer depending on whether I applied it to HTML or CSS or SVG. So that was the second bullet, finish the filter work. We have still some repainting issues related to text and T-span and all the related text layout features. That is partially because the SVG text implementation hasn't been revisited. So we're using in Legacy and LBSE the very same code for all of that. So all the performance issues and all the issues we have with the SVG text support and WebKit are still present in LBSE. We also have plans to tackle this, but later. So first of all, we need to get LBSE across the finish line so that we can turn it on by default. But of course, to reach that, we are not ready yet, because we need to verify, we need to perform a security audit. So once the design is stable, we need to run the whole machinery, fuzzing, ASIN, etc., and make sure that the new engine is free from use after free bugs and etc. So we need to do this kind of audit. That would be, if we had funding like the to-do list for the next few months. And then long-term is finishing the LBSE implementation. That means all layout tests have to pass. So out of the, I think, few thousands of SVG tests, we have a few hundred failing still because of individual bugs in LBSE, individual missing features. Some are obscure features not needed often in the wild. Some are quite prominent. SVG as image support, for instance, SVG as background image, as list image and whatever, they have still quite some bugs in LBSE, simply because we simply haven't started work on that yet. And then most important for us to be able to ship it is we need to ensure that LBSE is as fast as the legacy engine in any kind of standard benchmark. At the moment, that is quite hard to achieve. In the chosen design, we are creating layers for all SVG elements at present. So not selectively, as in WebKit, as in HTML land, where we only create layers under certain circumstances. For SVG at present, we create layers for everything. So you could think of LBSE as a stress test for the whole layer system in WebKit, because if you look at, let's say, the Tiger, the famous SVG Tiger, it creates thousands of layers. Hundreds of layers, not thousands. Many of them. And we need to find a design where we can selectively construct layers. To give you an example why that is hard, let's assume you're painting 3 rectangles, 3 div elements in HTML. You paint them in such a way you have a red one, covered by a blue one, covered by a yellow one. And you take the middle one and assign a transformation property to it. What happens, it takes that out of flow and it will paint on top. That is something, because HTML, CSS transformations do not affect layout. In SVG, it's complete opposite. So transformations do affect the layout. That means if we would use the same approach as HTML, CSS, and we would encounter in an SVG subtree one transformed element and only promote that to a layer, that would be painted on top, and SVG mandates that the painting order is the DOM order. So in order to maintain that, what we would need as minimum for these kind of constructs are 3 layers. 1 layer for the content prior to the transformed element and 1 for afterwards, so that we can maintain these orders. And these kind of tree transformations for the layer tree have to be implemented in order to reduce the layer overhead. And we have discussed this strategy with Apple, and they are happy with that approach, so we are going to test that as soon as we have bullet 1 funding for this work. And hopefully the final task, once we have fixed all the performance issues, is then turning on LBSE by default and getting rid of the legacy engine. Thanks for your attention.
Hi.
2 questions, if I can remember both of them. First one, I think I remember seeing paths inside of defs being kind of reusing the same path over and over again in multiple places. Does that also become a resource, actually?
No.
No.
No, that's just, I mean, you mean a path in a def section that's referenced by use elements, for instance?
Yeah.
No, that's not what we call a resource, no.
Yeah, okay. And then the other, in my talk, I mentioned the Hummingbird HTML renderer, and one of the things they did in their animation system was that because essentially the spec kind of says when you're doing an animation, you might be calling into JavaScript, and that of course creates the whole, like, you have the layout calls into layout problem. They split the difference by generating a list of things you need to do after you've kind of run this part of this spec algorithm through. Then you do the list of things which can call into whatever, and then you keep on continuing. Is that something you're also doing to kind of get rid of the layout calling into layout, or is that something that could be useful?
That could be useful in cases where you really need that. But here, it was just basically our laziness that we tried to reuse the existing mechanism instead of inventing something new. Because inventing something new for SVG back in 2004 was always seen with caution, because nobody needs that. Why do you introduce that? That was at really where HTML layout was still integer based, and nobody cared for SVG back then. I mean, not in terms of the existing browser windows. They tried to get SVG support, but with minimal impact, basically. Yeah.
Who's next?
So I don't know if you saw the recent State of HTML survey, but SVG was, among the things that developers cared a lot about and felt like needed a lot of work. And I guess I'm just wondering, do you have any insights into why it's so difficult to get anybody to spend on this, like browser vendors, or other companies so far, largely, to get some even collective group of people to say, yeah, we can see why this is really important for our thousands of businesses that use SVG. Yeah, do you have any thoughts that you?
I have some thoughts on this. What got us into that situation is basically WebKit. So all the advances in SVG, when SVG 2 was under development, and there was like a lot of traction around this. I mean, Emilia, one of them active writers of SVG 2, she wrote a book about using, one chapter is 3D transformations in SVG, like in 2012. And Firefox had an implementation like in, I guess, 2013, where this was possible. And there was always, Google was always looking at what is WebKit doing, and from WebKit the answer on any SVG topic is we are not going to do anything. Because the problem for Apple was they didn't have the experts on that, SVG. I mean, they could have hired, of course, people to do that. They didn't for some reason. I don't know why. But the problem is there was like no movement, and if you wanted to think about like advanced features, that always means a hell lot of engineering work before you can do that. And that's exactly the issue we have with LBSE. I mean, it takes so long because it's a lot of effort for basically no gain. So we are still, the old engine is still faster at the moment, still does more than our new engine. So it's hard work ahead before you can start about thinking about good new features. And there are a lot of things in SVG 2 that I personally would love to reactivate. But for this, we need to have this finished. That's why I'm always saying we need this funding to finally get this across the finish line. Then we can finally also attract more people, because then WebKit's position will no longer be, we won't do that, but at least a maybe, instead of direct rejection.
More questions? Anyone?
Thank you for the talk and improving like SVG support and potentially improving SVG support and WebKit. But given historically Chromium and WebKit share the same SVG engine, I was wondering if you could elaborate on the difference on approach that Chromium took in this resolving these issues. Like, how is it different? Is it worse or better, or do you know, really?
I cannot tell you this, because I haven't looked into details since this composite after paint system was introduced, because I don't know exactly. I couldn't give you a correct answer for this, so I would delay this to Chromium folks, what they actually changed in the past 3 years. I think the first composite after paint patch landed, but I do not know of the impact for SVG. I know that before that date it was very the same in Chromium basically.
But do they have hardware accelerated SVG?
Yes, they
support?
have this with this composite after paint, I think.
Right. Okay. So they did something.
Correct me if I'm wrong, Chromium folks, but I think they support it.
Okay, I'm super curious to learn what they did. Like, was it as big as project as you're working on, or they took some shortcuts? Who knows?
No, they use a completely different concept.
Right.
I mean, in SVG, in WebKit, we have to do the decision if an element is composited beforehand. Mm-hmm. So by looking at various things in CSS and some properties, we say, okay, this will need to be composited. And I think the cruxes of their approach is that they record all the painting operations and in the end decide if that should go into different layers. So it's a different concept, for sure, also interesting to explore. But we have now settled for this one. And
so yeah, architectural differences.
Yeah, it's an architectural difference. Yeah.
Okay, thank you.
Next question. Anyone? All right. Thank you, Nikolas.
Thank you.
By the way, before we finish, I'd like to remind you all that the walking tour starts at 6, so that's in 24 minutes, and it'll start from right in front. All right, thank you all for joining us today. See you.